Okay, well, good morning, participants, and welcome back. And today's morning session is on cloud IoT, and the resource person is Dr. Sendil Kumar, and he is associate professor in Amrita Vishwapeetham University, Coimbatore. And a brief profile about him is Dr. Sendil Kumar completed his BTech Computer Science Engineering from Setu Institute of Technology, Madurai. He then completed his MTech Distributed Computing System from Pondicherry Engineering College, Pondicherry. He completed his PhD in Information Communication Engineering from Anna University, Chennai. His area of interest include video surveillance, deep learning, cloud computing, software engineering, video processing, WSN, big data computing, embedded automation. He is currently working as an associate professor in Computer Science and Engineering Department at Amrita School of Engineering, Amrita Vishwapeetham, Coimbatore. He has received appreciation in Indian Express for agent-based programming for banking domain. He has publication in 9 national conferences, 12 international conferences, 14 international journal, and 2 edited book chapter. He has publication in 19 Scopus indexed publications. He has published a book on C++. He is a reviewer for Elsewhere Computers and Electrical Engineering Journal, IEEE Access, InterScience, International Journal of Intelligent Information Systems, IGI Global, Springer Data Analysis, International Institute of Engineers, Journal of Electronic Imaging, Computer Modeling Engineering and Sciences, IGI Global Publisher, Soft Computing, InterScience, Journal of Assistive Technology, Soft Computing, Journal of Assistive Technology, International Journal of Computational Medicine and Healthcare, Springer Soft Computing, Neural Computing Applications, Elsewhere Computer Methods and Programs in Biomedicine. He is guiding scholar with Amrita Vishwapeetham in area of video analytics, deep learning, signal processing. He teaches courses in video processing, video analytics, distributed systems, multidimensional signal processing. He has involved himself in developing competency areas of programming like MATLAB, NS2, GIST, Android, .NET, Hadoop, OpenCV, Spark, deep learning tools, embedded automation, etc. He is working with Amrita Vishwapeetham in Coimbatore since 2001. He is part of 100 projects with the IBM, DST, and Ministry of Tribal Affairs. And warmly welcome Dr. Sendil Kumar for today's morning session on Cloud IoT. And hand over session to Dr. Sendil Kumar, sir. Start, please.
Okay. So good morning, and thank you so much for the introduction, sir. It's been a good to discuss on a very upcoming area where people are trying to integrate data. Data challenge is seen in different spaces. Okay. So today's session, I want to walk through on talking to you about how IoT cloud altogether are coming together very nice from the user perspective. So I'm taking my session through 3 aspects. The first aspect is I would talk to you quickly about where is this IoT coming up right now in different applications. Then after that, I will talk to you about how to integrate cloud with IoT based application. So last part, we will see some data, and we will also talk to you about some algorithms which are there, which people can take it as a pathway for research. Okay. So with this small input, I feel we can start with the discussion. So I'll share the screen. Just acknowledge me whether, sir, I think you have to enable me for sharing screen, sir. Hello. Sir?
Yes, sir. 1 second, sir.
Yeah.
Yes, sir. I made you as co-host, sir.
Okay. Thank you, sir. Thank you. So, yeah. Right. So this is the first one which I want to take through on understanding where this IoT data analytics altogether is coming with this keyword called as AI, that is artificial intelligence. You would have experts who have talked to you about all this interdisciplinary areas. So I'm sharing a slide which is provided as part of copyright, which is on the internet. So because this is very good and this talks through very live examples. See, when you say that you have been having IoT as a solution, the answer is like wherever there are applications, you are interested in having some sort of an embedded device which can actually process a live data. For typical example is like if there can be a camera in my home which can record all the data and it can do some processing. That's an example of an IoT application. If I have a sensor-based automation in the agricultural field, which can measure the temperature, humidity, and it can give me some live input about how much amount of weather is there and how much amount of water has to be provided to the region. That is again an example of IoT. So what has happened is like the data is keeping on increasing. How do you say the data is increasing, right? Now we will bring in the first keyword which says cloud, right? Okay. So cloud says that it is a facility where you can provide end user anything the user wants as a service. So there people will talk to you about the infrastructure as a service, platform as a service, software as a service. So example of a software as a service is if you have an accounting application, right? And you have not purchased a license on your desktop, but if you are using it on the cloud, that is an example of software as a service. So most of the applications we build on the cloud are actually software as a service, right? Only thing is they will run on the cloud environment, right? Now, why are we talking about cloud with respect to this data? That's the first question. See, cloud said that I will give you a facility where you can manage the data in more of a distributed model. So that is where people started shifting all perspectives of data to cloud. Right? We'll spend some time on it in the coming slides. And next is the users. So the number of users who are actually working on the data also has increased. For example, if I ask like how many of you are using a Google map, you would say in the beginning of the day it is 100,000 and you would say it is lakhs and lakhs of people are trying to use Google map. But if you ask the user who is trying to hit for a location, let's take he wants to travel to Ramanathapuram. At the same time, some other user also will try to hit the location for Ramanathapuram from a source location. So there are many users trying to hit the same target data, but the user's expectation is different. Like I want to travel from Coimbatore to Ramanathapuram, but somebody else will say that I want to travel from Madurai to Ramanathapuram. But still the algorithm works. It gives you the very easiest path to reach from your source to destination. So users have increased, right? And the third is today we want data from everything. For example, people say that I want to reduce my weight. They say I got a smartwatch. So my smartwatch will pick up the data of whatever I do from the morning. I walk 10 steps up, it measures. I walk 10 steps down, it measures again. So we are taking data from all possible sources and we are trying to integrate the data. So this has led to the field of saying that this concept of data is no more a small data because it is growing with time. For example, if I wear a smartwatch, right, for 6 hours, so you would say how much records you will get? You will get records for 6 hours. That means you will get 6 entries, right? So if you look at the 6 entries of the data, what you will get, right? Then people will say that my entries of data as such would be a notepad file, right? Which will actually take me through saying that each rows of the data are corresponding to a hour, right? Each row of data that I take here is corresponding to a hour. But if I'm going to measure it in terms of minutes, then the next answer people say is if it is in terms of minute, so it is 6 hours. So 6 into 1 hour 60 minutes, right? So you say 6 into 60. That means you'll get 3,600 records. Now, if you're going to measure it in terms of seconds, then you would say 6 into 60 into again 60 because 1 hour, 1 minute is again equivalent to 60 seconds. See the size of the data, right? So what I'm trying to explain to everybody is like the data is keeping on increasing, right? That's the first information for all of us. 1 second. Yeah. So once the data keeps on increasing, now the challenge is the data is no more a small data, it becomes a big data. So you need algorithms which are smart, which can actually pick up this big data and do some processing back to the end user, right? So that's where AI took up its place. Artificial intelligence is now everywhere in terms of automation because it can give you the users what the user wants with a quicker amount of time and with a higher amount of accuracy. So whenever you look at any application, please go to the application and ask, okay, where is an IoT? Where is the concept of AI? Where is the concept of big data? Right? For example, let's take one of the examples that you can see from this list. Let's take, I take an example of micropayment. Right? For example, each one of us, when you are using a Google Pay, for example, I'm just saying Google Pay for an example. Right? When you're making a payment, you would say that there is a user who's going to be receiving the money. There's a sender who is sending the money. So every transaction is recorded, right? Now, if I ask like how many transactions I would make, let's take I want to make payment for the food 3 times a day, then you would say you would make at least 3 transactions. If it is a month, you would say 3 into 30, at least 90 days, right? So it is 90 transactions. At the end of 90 transactions, you can see parallelly that the corresponding provider, be it a Google or Amazon, would say, okay, you are eligible for a discount, you are eligible for a benefit, right? So each and everything is recorded at a micro level. And algorithms work behind that. The algorithms could be, an example is your AI-based algorithms, which could be an algorithm which is based on reinforcement learning, which would come back to you and say that, see, you are eligible for 10 rupees discount, or you are eligible for an offer from Lenskart. So anywhere the data is taken in form of an embedded device, there you can say it is an IoT based application. So your mobile, which is actually recording your activities basically with respect to your heartbeats and so on, that is again an example of an IoT based application. So what I am leaving to the people to understand is, whenever you look at application, just go and ask what are the sensors where it will be used. If the sensors can measure the data, what can I do with the data? Right. The third thing is, okay, there is some data. Can the data become very intelligent by using some sort of algorithms from AI or deep learning or transfer learning? So when you look at IoT, right, in terms of the process level, this is how the industry actually talks about. They say that everything is possibly integrated on the network as a cloud. Today, if you ask somebody where's your data, they would say it is on the cloud. So first level is the cloud infrastructure where all your data is coming. The second level is the edge computing. What is this edge computing is like the end devices have the capability to do the computing. For example, if you go to 15 years back, we would say that we will have a server. Okay, we will have a server and the server will actually do the processing and come back with a result. But nowadays people say that we do not have a server, but instead the mobiles or the system, which is at the end device, has the capability to do the computing. So that's called as edge computing, right? Okay. So what can be there in the edge computing is anything which is a device. It can be, you can say device, you can say sensors, or anything that you can say as part of an IoT, which is an embedded device, is also part of an edge. So this is what is the transition that we are having nowadays. Any part of application that you work is actually part of an edge computing, and the devices that is there is part on the edge. Now, what would be the role of big data and AI, right? So AI actually looks at more at the data part. So whenever there is data, you can write algorithms using AI and you can provide the end user with intelligent outputs. The big data will come up wherever you are trying to have some data. As I told you, if I'm going to have data from sensors in the agricultural field, the amount of data that you collect, you can call it as a big data there. Now let's take one example here, which is being discussed, which is automobile IoT, right? Okay. So here, this example is neatly says that there is something which needs to be taken as part of the data, and they are looking at basically the supply and demand matching. Now, if you look in the diagram, the same components will come up. There is something at the data part, there is something to be done at the edge computing, and there's something to be done at the edge level, that is at the node level. So what they are looking at is possibility of some sort of an optimization on every data that is collected in the automobile. So the other example that is presented here is port IoT. What is this port IoT is like, if you look at the data that you actually collect with respect to the ports, you know what a port and hardware is, right? You are in real time, you are trying to collect some data. So how do you explain this thought process? Let's see here. There is an amount of items that goes through the cargo from one source to the destination, right? Okay. So once it is traveling through the cargo, right, via the ship, right? Once it goes to the destination, if you really want to get this items delivered to the end users. So what generally happens is you can actually look at logistics, which can actually go via the ship. It can get delivered to the destination. Or what might happen is there may be a delivery from the ship to the flight, and then it can deliver back to the destination. Right. So whatever it is, your first question that you are asking is, what are the items that I want to do on the shipment? Right. Okay. So if you say I got n number of items, then the next question you will be interested to know is, an end user will be interested to know, where is the cargo right now? If the ship has started from the source, where is the cargo? So the user wants to know some sort of portion of the cargo as it is traveling, right? So you want to have some sort of monitoring. Then the next is like, you need to give some end user input saying that the ship is delayed by 6 hours or 2 hours. You need to give back the user saying that there is amount of time at which you will get your product on delivery. Now the product on delivery that you are trying to provide, right, is moving from the ship, which is up from the cargo, onto a truck, and then it is supposed to go from the source to the destination. And at every time what you want, you really want to know that where is the product. For example, if you book something in the Flipkart or Amazon nowadays, you would actually get a message saying that the delivery time is 2 days. But once it is got shipped from there, it will automatically say it is ready to shipment. Then they will say that you can have a tracking, and that will say that it is dispatched, it is reaching a place, 6 hours, 2 hours, 1 hour, you will get your product delivered. So this is a very good example of an IoT based. So here, where is an IoT coming up, right? That's the next question, right? You are trying to label each of the cargo products, right? So the cargoes will have some sort of sensors. So the sensors will allow you to pick up the signals, and they will give some information to the software saying where the cargo is, right? So that is what is an example that is discussed here. So the advantage that they have presented from the use case perspective is like, you are trying to monitor the cargo, right, with less cost per container if you're going for an IoT based application. And it is more competitive solution for the shipment of products, and more amount of income also comes from this. Now, we have said two things in the previous two slides, right? For example, if you see the first one that we told you is providing an optimization, that is OT, right, for the food application. Now, if you can integrate this OT plus IT, right? So what is this IT here is what has been discussed here. You can see here. You want to integrate IT together, then what you can build would be something called a smart logistics. So what is this smart logistics is? If you look at this space that they are trying to discuss, they say that wherever the user is there, if the user is actually part of a warehouse, you know what a warehouse is, right? Where all the items are getting stocked. If you see the biggest warehouse, they would say it is for several kilometers away. So the person who is actually in charge of the warehouse wants to take a stock of the items, right, that has come up through the warehouse. The person can wear a glass, which is based on augmented reality. So this will be called as a smart glass, right? So this smart glass actually can pick up the details of any product that is in view as it is coming for delivery, and it will give you real-time logistics. That means anytime you will be able to get the details of the product that is arrived or that is ready for shipment. Now, this entire network, now if you bring in a concept of networking, if this space is very large, the marketing person can actually move around the space anywhere and try to pick up any item. So there needs to be possibility for a network scenario. So the suggestion is you can have some sort of an automation using a Wi-Fi, and that can actually pick up the location, and that can connect the information. What is the information here is, for example, if you assume that there's a product that has come through the cargo and it is ready for here on the shelf. Now I want to keep track of this product, right? And I want to inform to the person who is at the desk here, because you want to give some real-time logistics. So that can be done because there's a networking in place. Now, where will AI, automation part, come up with artificial intelligences? AI will suggest which can be the best place where you can place. For example, if there's a set of products that has arrived, now you want to know where you want to place these products within the space Now, the artificial intelligence will say, this is a shelf, this is a place where you can go and place those particular products, right? So artificial intelligence is used for space allocation of any of the product that has arrived on the cargo, right? So this is what is called as smart logistics, and this is really used in companies nowadays. You take many of the biggest players, like we talk about Blue Dot or any of the leading cargo suppliers, their logistics internal management is built on AI. So next is smart cities, because this is close to what we are hearing nowadays, even in India. We are talking about we want to have a smarter city, we want to have facilities where people are trying to connect, where everybody is safe as part of the smart cities. Now, here, if you want to provide an IoT as a solution, what is being discussed is, first part is like the devices that we are going to provide in IoT will generate data faster, right, than what the IT infrastructures. Because if you ask everybody saying that what will be the future of IoT, if somebody stands up and says that, see, once we are all becoming smart cities, every places will be cameras, right? And cameras will monitor our movements within the particular city. Now the question is like, okay, the camera will record the data, but do we have an IT backbone network which will actually process the data faster? So that's the next challenge that is coming up now. So IoT will say that the devices can actually measure the data. But the question is like, once the data is measured, is there a capability in the backbone of the network which will actually process the data? Right. So this will bring in some effort for us to process. So you want to use artificial intelligence as part of IoT, that is in edge computing, and you want to use AI as part of the backbone of the network also. So this is what is proposed as a solution. Now, when all this is taken, you can assume that if you want to take all of this on the cloud, this cloud perspective will go from any device to any device at the edge level. Look at this here. For example, if you look at this right side of the application, you can see homes, right, including any one of your home, which is connected on a smart city model. Then you have industrial devices, which is also connected on the smart city model. You have wearables, which is also connected on the smart city model. You have telematics, which is also connected on the smart city model. This agent that we are trying to provide here is nothing but a program that runs at the end user devices. It can be at the telematics, wearables, industrial devices, right? Now, when all this data is coming up, the backbone of the network is the first challenge. So you need to have a strong backbone network which acquires the data which is coming from these devices and processes the data for processing. Now, once this data is coming up, we need a cloud which can actually store the data and give us quicker analytics, right? So that's the meaning of this diagram. Left side, what you see is actually the blocks that are there. Class. Oh. Yeah. So what you see here is the different blocks that are part of the model, right? For example, you as such will try to write each of the processing blocks. You write it through a flow editor, and the flow definition will be part of a JSON file. We'll pass the JSON file onto the cloud, and the cloud as such will be able to process the live data that is coming, because we are saying that the cloud is able to pick up the data from the different streams. So what are the streams it can process would be is, first it can pick up the data from the server, it can pick up the data from the gateway, it can pick up the data from the microcontrollers. So the statistics on the net says that if you want to talk about the data, all the data that we are now just having has been just the data that we got in the last 2 years. And most of the data are web-based data only. Now what we want to do is we want to integrate all of this data with the IoT devices and do real-time computing. So when you want to minimize any sort of an IoT data, so you need to actually extract the required data alone. The devices will give a lot of data, but rather than using all the data, you can extract the required data alone and use it for processing. There, what you talk about is something called as metadata. So here, this is a very good example for understanding how IoT and edge computing can go together. For example, let's take, we are looking at this application as an application for an academic environment. Let's take it like that. So in an academic environment, in a college, there are a lot of cameras everywhere, right? So now the cameras are there at every place. For example, if I assume that there are three floors, floor one, floor two, floor three, each floor I have one camera, right? Rather than recording the entire data and store it on the cloud, I can try to generate the metadata that I want and push it onto the cloud. Now, what can be this metadata? For example, I just want to know the people and their location. For example, every time I want to write it to a notepad file saying person one, comma, date, comma, time, right? This is the information I want to write. Now, the same person one who is at the second floor can actually come to the first floor also, right? For example, if I'm in the second floor, I might walk one step down and come to the first floor. Once I come to the first floor, my metadata will say person one, right? Date, time, right? So this is the metadata I just want. This data, I would like to store it and I want to process it for the real time. So how does this happen? How does this data gets processed together? Now my edge computing will say, you have two pieces of data. Person one at date and time, person one at date and time. But the person is appearing in two different floors, right? Second floor, first floor. Now, if the end user wants to know where the person one is, my application should say that the person one is now available in first floor, but the person one was also available in the second floor sometime earlier. Right, okay. So this is a small example which I'm talking in terms of edge computing. Now, once this data is picked up, then there is a processing engine which you can call it as a data path engine, and this together can be integrated with some sort of a cyber physical system. So what can be the cyber physical system? As I told you, one data that you can generate is person one is at second floor, was originally in first floor, right? It can be on the web browser where you can see all the analytics are on the web. It's called as web analytics. So we are integrating this data with the personal data and we can do some sort of analysis. One analysis would be like, let's take it as a college, right? And one parent has come to see the kid, right, at the college. The parent is trying to come to the class, the parent student is not there. The software can say the student was seen at second floor at so and so date and time, right? So that will help us to backtrack and say, okay, where the student is right. So this is a small example for you to know how systems can work. Now, when this becomes an end user facility, it can be on the system or it can be on the mobile, right? Where you will say that I've integrated some data with the sort of embedded applications, which can be a DSP-based applications. So whenever you want to bring an AI, artificial intelligence, into IoT, then the next question somebody would ask is, okay, what is the data that you're going to process, right? If you talk about this application that we have shown, right, where we are trying to record data from the cameras, people say first data that I might get is an image. I will really get some sound also, right, because I'm recording a video. So I will have image and sound where I can go to artificial intelligence and say that I will use an algorithm which is CNN, convolutional neural network, which is part of a deep learning architecture. And the second type of data that you will get is the temporal data, right, which is a transactional data, which can be some sort of sequences. For example, if I talk about this data, I would actually say that in the notepad file, I'll have person one, I'll have the date and time, person two, date and time, person three, date and time, person four, date and time. Now, if you ask a basic question, when will you record the data? If I'm saying I'm recording every minute, so if it is 1 hour, I would have got 60 records. If it's 2 hours, I would have got 120 records. If it's 10 hours, I would have got 600 records for this camera. Now see the size of the data. The data is keeping on increasing, but it is not a data of image we are talking about. It is a data of synthetic data, which is stored into a text file. So there, the architecture that you can use would be an LSTM architecture, which is long short-term memory architecture. The third type of data will be an NLP-based data. So what is this NLP-based data would be is like, let's take at the end user side, the user is searching for a person in the campus. The person enters saying roll number, comma, name. So that becomes an input, which becomes a textual grammar, So now the text can become very intelligent, saying, I might ask like, when is this person with roll number seen in the last 2 hours? It can come back and say the person was seen at 9 o'clock at first floor, 9:10 at second floor, 9:15 at first floor, 9:16 at second floor, and so on. So you are trying to build some sort of an NLP-based model for the user input. The user will just type the text as a question and that can come back as answers. So there you can actually use NLP-based algorithms which are there for AI. The next is a behavior. See, whenever you talk about reinforcement learning will say that I will give you some sort of analysis based on what I have captured from the environment. So the environment becomes the input for myself for understanding, right? So there people can actually use reinforcement learning. Now what we are trying to give you connectors from this example, if you want to bring in an AI, where will AI come up for the different data sets? So again, I'm keeping this point for the participants. You will have to spend some time to understand what is the data that you're going to process and when will you need the data for the problem. We do not know that, then it becomes very hard, right, in the later part of solving this problem. Now, let's look at the verticals. So this is your IoT vertical, and this is the AI that has been presented for the same. If you talk about an IoT vertical for manufacturing, they are saying that with respect to AI, we can try to apply something on predictive maintenance, then you can use anomaly detection, okay? You can use missing event interpolation, right? All that you can do with respect to manufacturing. If it is marketing, you can use churn modeling, you can use behavioral prediction as part of marketing. If it is sales, you can look at how much customers will stay with you for an overall amount of time as part of AI, right? So if you can see here, even if it is talk about the vertical part, or if you talk about the horizontal part, right, every time what we are talking about is data. So the data gathering process, which people talk about called as crowdsourcing, is a very important scope of building any sort of AI with cloud. So this is the new keyword which people are talking about, data. Data is everything that you want to do. So if you are trying to have a solution for a business, you would actually be asking a question, is your business is willing to share their most valued asset, right? So there the answer would be like the business is around data. How do you say this data is very important? Let's give an example. Let's take you are part of a organization which actually has around 100 lakh customers, right, with your organization. Please understand, 100 lakh customers. Now, let's take your data is taken by somebody without your knowledge. So that person, if they know the business, they can talk to the 100 lakh customers. And out of that 100 lakh, at least 1,000 customers will get converted to the new company. I hope people can try to understand. So data is a very important thing because data has got a lot of value and it is immeasurable in terms of the amount of advantage it gives to your problem. So as you say, if you do not have proper rain, then that case the plants are not going to come up. The same way you need a right data to look at problem solving. So every time what is now industry is talking about is industry says that we need to have the possibility of inventicizing the data and we need to have the shape of the data flow for the data providers, right? So here two main people which will come from the industry side is one is the customers and second that will come up with respect to business. So here I'm just keeping one slide and then after that I'll come back to the algorithms part. So here when you look at data model and AI exchange, right? So the first thing that you need to understand is like every data today needs to be understood and provided to the users. So data is not at one place, data is everywhere. So we are actually going from a possibility of a centralized security model to a distributed security model. So what is the centralized security is like if you take 10 years back, people will say that I have data, I'm using an RSA algorithm to encrypt the data. I'm using an AES algorithm to encrypt the data. But nowadays people say that I'm using a blockchain, the blockchain will take care of securing my data. So what about the blockchain concept is, as you all know, the concept of blockchain will say that the data as such right? Whatever you're trying to present is not secure just because of one system. It is because of all the users in the model. So if there are 10 users in the model, all the 10 users will agree on the consensus algorithm and they will say that the data is secure. So if the data is not secured, or otherwise if you ask me a question that the data is being hacked by some person outside, it means that all the users who are part of the consensus algorithm are responsible for the security problem. Right? It is not the server alone. So that is where blockchain became very popular. Right? Today, most of the problem solutions are shifting to blockchain because the security or the trust level that we get in blockchain is very high. Right? So that's the purpose of this slide. So in summary, the first part of the presentation, which I wanted people to know is we are having cloud as a facility. We are having IoT as a part of end user request. The end user says that, see, no more concept of having data being filled. I want to have an IoT. Like for example, if you go to a mall, people say that you need not actually come and take your product. Wherever you're going, you can actually scan the product and the product will come with respect to your user ID and as a bill, right? So that's an example of an IoT. So the users want smart analytics. The users want a smart way of processing the data, right? So their IoT has become a need. The third aspect is like when the users are going to have data, there are lots of data that is coming up, and this data is very important for some reasons. So there, the question would be like you need some algorithms which will take care of this live process. So there, the algorithms that are there is artificial intelligence, or now people talk about machine learning, people talk about deep learning. All these algorithms are in place to make all these models better. Right. So this is the first part of the session that I want people to know. The second part of the session, I will actually go to the cloud part. Any questions from the participants? Participants, any questions from your side? Participants, any questions? Am I audible?
No, sir, no questions.
Okay, fine. Now let's look at the data part, right? How will our data come up, right, for our advantage, so that when we discuss on cloud, it will be very nice to get things going very well. So if you look at this data part, we talk about the fields. So the fields that we are talking about is flow, right? Person ID, and next is time. Okay. So there are 4 attributes here. So the attributes are flow, person ID, date, and next is time. This is for a scenario that we discussed. We said that cameras are everywhere in the building, so we can monitor where the person is available. Now, if you look at this here, let's take, I say, flow 1, right? So person ID is 101. So date, let's take, we say 25th October. We say 9:01 AM, right? Similarly, flow 2, ID is 102, 25th October, 9:02 AM. 103, 26th October, 9:05 AM. Okay. This is one piece of data that gets recorded. Now, if you ask like how long the recording will go, you will see that whenever you are switched on the camera, the data gets recorded. And how much will be the size of the data? Everybody will come back and say that it is based on date, right? It's based on time, it's based on seconds. So naturally the data will be recorded for every second. Okay. Now, when such a data is recorded, now what happens is you are talking about end user visualization. Right. So for example, you have an application which is based on smart analytics and you want to get some data. Now, for example, somebody says that there is person now, right? If this is a question you are asking. Now means the current date and current time, right? Okay. So now, if you say now, for example, and now points to, we are talking about 10:04 p.m. 10:04 a.m. Now it's 10:04 a.m. Now it automatically goes to this record. It doesn't find anything with respect to 10:04, right? It might come back with an answer saying that person 1 was found. You can see here floor 1, right, 9:1 a.m. Right? Okay. Now, how does this come up, right? So when somebody is typing a query like this, the query that you write may be understood as an NLP model, right? And for this data to come back, like saying that the person was found at floor 1 in 9 a.m., right? This requires some sort of algorithms where the algorithms can be in terms of artificial intelligence, or it can be in terms of machine learning, or it can be in terms of deep learning. Right. This is one way of asking the question. Right. Okay. Now, if you are getting next data, okay, let's take this says 101. It says 26 October. It is 5 a.m. Right. Okay. Now, if I ask a question again, right, saying where is the person one now? Right. Okay. Then everybody will say from the records, if there is a record right now entry pointing at 10:05, right? It says 10:05 a.m. right? But if I ask one more question, the question is something like, where will the person 1 be at 10:10 a.m.? Right? Please understand the question. I'm asking on the future side. Where will this person 1 be at 10:10 a.m.? Now, if the software has to come back to me, then it will say that I'm using concept of something with respect to predictive analytics, right? So I will use some algorithms that are there for predictive analytics, and the algorithms will come back and say that the person will be at floor 1 or floor 2 based on this data. This is a small data that I've shown, but the data will be very large. I think people will understand, right? Okay. It's not just going to be data of 4 records, it's going to be hundreds and thousands of records. So at the end of the day, with these thousands of records, my algorithms will run and will quickly come back to me and say that, see, come on, the person is be available at the floor 1 or floor 2 or floor 3 or floor 4, right? Provided there are only 4 floors in the building. Right, okay. So this is what we are talking about, data and analytics. Now, if I ask, okay, where will be the IoT concept coming? Then people say, where is IoT? Then you can say, come on, I'm using some cameras. So naturally, the data is getting acquired using IoT. So if somebody is asking, where is analytics coming? Then you would say, I have a lot of questions which I can ask on this data. The algorithms are helping me out. So I'm using something from AI, or I'm using something from machine learning, or I'm using something from deep learning to give me the answers. So that's why you talk about IoT and analytics. Now there's a third question which somebody would ask you, where is cloud coming? There people say that, see, this is my data, but this data I have pushed onto a hadoop, or I pushed onto an AWS, right? I'm doing all the analysis on the cloud. So there you would say that cloud is there in picture. Right. This is a smaller example, but you can really accept with me saying that if this data is recorded every minute and every second, this data becomes very large, and the questions that you can ask on the data can keep on increasing based on what you want. And whenever the questions are intelligent, the algorithms also has to become very improved and has to come back with the right answer. Right. And here the other challenges also will come up. For example, if you look at this data that you have captured from the camera, it's not going to be clear data. For example, if I put on my camera now, it's a good sunlight, so my data is good, your algorithm also works very well. But let's take it's raining, it's totally dark, right? The data recorded is also not good. So that the camera will have a lot of problems. Right? So the camera will say that it is having some sort of noise. In data level itself. So there, when you look at the algorithms for analytics, they will say that I'm using some algorithms which are based for noise handling from image processing. Right. So this is how any problem that you take, it's going to give you an interesting solution. So data is acquired. Once the data is acquired, certain end user aspects will be answered directly, but certain end user aspects will be answered only through predictive analytics. So there you will use algorithms which can be on artificial intelligence or machine learning or deep learning. Now where will be the cloud coming up? I'm pushing the data to the cloud. So my infrastructure can be in terms of Hadoop, or my infrastructure can be in terms of AWS or any other cloud which services which are there on the internet. Right. Any questions from the participants? Participants, any questions? Am I audible? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Sir, can you just re-explain this thing in a short span? Actually, some parts, if you can re-explain some part of it in a gist, please.
Re-explain which part, sir? You want to explain?
This example where cameras are capturing the images of a person on different floors, and using that data, future positioning is determined.
Correct.
In a gist, can explain, sir.
So I didn't get the last word. We're asking that what I'm showing you is an example of camera which is recording data, right? So the camera is giving analysis and the data is stored. And if the user has some questions, the questions are answered from this data directly, or participants, am I audible now?
Yes, sir. Now you are audible.
Yeah, were you able to get the answer, sir, or did we lose the connection?
We lost the connection, sir.
Oh, sorry. Okay, 1 second. See, what I told is the camera is recording data everywhere, right? So once the camera is recording the data, I can actually ask some questions to get some quick answers. For example, I'm searching for a person. Where's a person now? It can actually say person 1 is now available at so and so time. Let's take the time is right now 10:04, right? So at 10:04 I don't have a record for the person 1. So it will say me that the person 1 was actually available at 9:01 a.m. This person 1 in the sense I'm indicating with respect to 101, person ID 101, right? Now, if I ask like a new record with being entered 101 with 10:05 a.m. If I ask now where's the person now, since the time matches to the current time, it says the person 101 is available at 10:05 a.m. at floor 1. Now, if I ask a question in the forward, where will be the person 1, that is 101, be available at 10 a.m. But I have data till only 10:05, and moreover, the current time is also 10:05. So there, predictive analytics will come in picture. Algorithms for predictive analytics will come in, and it will say that based on the past data, I can give you a prediction that the person 1, that is 101, can move to floor 1 or can be in floor 2 or floor 3. So if you happen to do all this, what you're doing is you're using algorithms from A or ML or deep learning, which comes into data analytics. Since your data is pushed on the cloud and your algorithms are going to run on the cloud, they are used cloud concept. So your cloud can be open source cloud, which can be on Hadoop or it can be on AWS, right? Or any third party services which is on cloud. Now the other challenge which I told is if the data that you're recording is having some sort of noise. For example, if you talk about cameras, the climate changes. There's a lot of rain there. So noise will come up there. So you cannot just take the data and you cannot just do the analysis. So you would say that I will have some algorithms for handling the noise. Because if you look at this here, the input that is captured is actually images, right? On the images that you have captured the data, you are actually generating a file like this, saying floor 1. Floor 1 will be automatically identified. How? With a camera number, you can say which floor it is. But you have to recognize the person, right? So the person recognition will be done by using the algorithm. So given an image or video recorded from the camera, you will have some algorithms for person recognition, right? And that will actually take the data to a file like this. But if the person recognition algorithm is not working correctly because there is some noise, there you need some denoising algorithms which will be used. So this denoising algorithms can be running separately, or this denoising algorithms can actually run as part of your deep learning architecture itself. So this is what I told. Is it answered, sir, to your question?
Yes, sir, absolutely. Actually, I had one additional question in respect to this. Suppose as you said that there is some noise, disturbance in the medium where cameras are recording. So the data that the cameras receive is full of ambiguity. So instead of analyzing a person, suppose we have a cat on that floor and the camera records it wrongly, the data that is received by the camera is faulty or has ambiguity. It considers a cat as a person, and based on that, all algorithms are running, and I am getting a prediction that the person might be on this floor, whereas actually a cat is on that particular floor. So how can we deal with this kind of ambiguity? Because it is not a person who can tell that it is not a person or a human being, it is a cat. But how a machine will differ when in case of the ambiguity of data? Actually, it is sensor data that is faulty and leading to erroneous result.
Okay, so I got your question. See, wherever you are talking about data and analytics, you will actually have two types of data. One data is going to be your training data and your testing data, right? Now, if you talk about a person recognition problem, you would actually say that you have data which is for training, you have some data which is for testing. So if you ask like what is the person recognition data which is for training, then you would say that again, I will have some samples which is positive samples and you will have some samples which is for negative samples, right? So now if you talk about the positive samples means anything which is basically indicating a person face, right? It can be a person who is there in the office or it can be a person who is not in the office also, but it's a person face. So you will say you are training with faces of person. Right? If you talk about the negative images, right? Negative images means it is not person-like images, right? It is not a person at all. That's a person. So when you talk about negative images, let's take for example, just for an example, somebody's face actually resembles something with respect to an animal, right? So the face texture is like that, the color is like that, right? Okay, so you are trying to give negative images. This negative images includes anything which can be an animal or any sort of an object which has got characteristics of a person. Fine. So you are the person who is going to train your model with the data set. So if you are intelligent in training your model with possibly saying all possible faces, all non-possible faces, which is negative images, there when you are going to have a test data, this test data is going to come from the camera. So once a camera is going to pick up a face, and let's take it as a face of a cat, that's what you say, then automatically the next person would, if somebody would ask is, will cat be recognized as a human? So here, if you talk about the algorithms that are there, if you go back to deep learning and start asking, they would say that you can use a CNN architecture to solve the problem. Because CNN will say, use the positive images as faces of person, use the negative images as non-faces of the person, right? Over the years, what has happened is, there are characteristics of the object which might resemble to some other object. For example, let's take, I see an object from a longer distance. It looks like a person, but it's not a person because the camera acquisition also has some problem. As you said, no, it has some noise. So I'm getting a partial face. The partial face looks like a human, but it's not a human. There people talked about architectures, which are now popular, which is called as GAN architectures, generative adversarial network architectures. So the advantage of this architecture is this architecture can actually capture all the characteristics of the features and it can say whether it is a real or whether it's a fake. Right. So here you are saying whether it's a real person or whether it's a fake person. So you, as much as possible, can actually use this architecture and say, I'm giving you a partial face which resembles a human face, right? But it's not a human face. That case, what happens is the GAN architecture will have a generator and adversar through which it can become intelligent. So this is how the models can be becoming intelligent. So question is valid. Solution to the question would be like you can use a GAN architecture to solve the problem.
Thank you, sir. Thank you. Thank you very much.
Thank you.
Absolutely. Yeah.
Any other questions from anybody?
Sir, I have a question, sir.
Yes, ma'am.
Sir, in the data, what proportion of data should be chosen for testing and training, sir?
Just like this, ma'am. Training, you should choose 70% of the data, right? 70% is a training part.
Okay.
And testing, you should choose 30% of the data. So it's like you have 100 images. So you can choose 70 images for training and 30 images for testing. But again, within that, the normal rule is you should have more of negative images, right? Because you want to reduce the number of false positives. So negative images should be more when you're considering this training and testing.
Is there any proportion for that, sir? Negative images?
Yeah, negative image can be, it is generally said, it can be twice the count of positive samples. That's what papers generally say.
Okay.
So
Thank you, sir. Thank you, sir.
Yeah, thank you. Thank you. Any other question? Okay, fine. So thanks for asking the question. It makes everyone of us to learn something more. That's all. Okay, now we will move to the next part. Now the question here is like, I want to do something on the cloud. Okay, so the data is there. I want to do something on the cloud. So there the question would be is like, if cloud can be a solution to the problem, then cloud deployment is a second challenge. Now, when you look at cloud infrastructures, there are generally two aspects to it. One, infrastructures will support saying that everything is free. That means you have computers, you can set up your cloud, right? Another set of infrastructure will say that no, it's not free. You actually rely with us. We will have a minimal cost for it. But both have their own advantages, right? If you come to your own infrastructure, you are investing everything in terms of your computer, server, and your facilities, and you have set up your cloud. If you come to an infrastructure investment where you are relying on a third party, they have their own facility. So that facility will be used for your requirement, right? So both have their own advantages and disadvantages. But I want to talk to you on setting up a cloud infrastructure where your infrastructure is based on your open setup. That means you have computers, you can actually set up your cloud, right? So that's a discussion now. So we will take through that. Once again. Open the presentation. Yes. Yeah. So just acknowledge me as you are able to see the slide. Are you able to see my screen, participants?
Yes,
Hello?
sir.
Yes, sir.
Yes, sir.
Okay, thank you. Now what we'll do is we will take through this platform, which has been popular. Even now it's popular, right? Okay. Only thing is a little bit of patience is required using the concepts of Hadoop. That's all. Now, what we'll discuss now is how to take through Hadoop as a possible solution, right, for setting up any sort of models which are need to run. So as far as Hadoop is concerned, there are three things that needs to be known in Hadoop. So we will discuss on that. Before that, I keep my acknowledgements okay, to this instructor. So I'm sharing the material from which is provided by the instructor Nalini Venkateswaramani as part of the course which is distributed systems middleware, right? So when you talk about Hadoop, the advantage of Hadoop is very simple. Hadoop says that it's a complete open source. You need not spend even ₹1 money for enjoying a service. All you need is only computer, right? And the advantage of Hadoop is Hadoop says that you can actually have a data, and that data can be processed efficiently if you have a cloud infrastructure. Now, if you go back to the small history, right, okay, how things has come up in the past years, right? In 1996, if you go back, we had been having this Lycos platform. 1997, as you can see here, hotbot platforms, then Excite, and so on. So now everything is that when one thing very common. It said that you have something as a question. You just ask me. I will actually go to the data and come back with an answer. So it can be a normal web search engine, or it can be a data inference that you're asking from the user perspective. So there, Google became very popular over the years, right? Now, if you ask anything people want to search, they will go to Google and type. But Google is also intelligent. Google will say that, is this the data that you're closely looking for? If you make a mistake, it says, there's an error in the word. Is that this word that you're looking for, right? Okay, so that's what Google has given us, and it is giving us more and more better. Now, when we talk about Hadoop, Hadoop was actually proposed in the year 2005, right, by these two people, which is Doug Hetting and Michael J. Kefria, and they established this concept of Hadoop. And this was further funded by Yahoo, and it became part of the Apache software platform. Now, when you look at Hadoop, Hadoop gives you concepts which has improved over the years. In 2003, it said that the data that you want to process, just now we saw a text file, no? I'll come back to the file and show you how the Hadoop can work better, right? So in 2003, Hadoop said that I'll give you a concept of something called as HDFS, Hadoop Distributed File System, right? And Hadoop said, okay, I'm not giving you only a file system model, I'll give you one more additional concept which is called as a MapReduce, which will give you quicker processing on the data. Because the challenge with us is we have records, we have data, but the records are very high. It is 100,000, 100 million records. But I want to go to the data and quickly get an analysis back. So there, MapReduce has been the solution. The next one is HBase, which is basically the Apache platform, which is provided as part of the Hadoop. HBase is again very intelligently used with the Hadoop. So this is small recognitions just for people to know. Like, okay, in 2008, Hadoop was said to be the very promising platform for storage of data. In 2013 onwards, we got the quick versions, 1.1.2, 2.0.3 alpha versions came up. And along with that, they added Mahout, M-A-H-O-U-T. This advantage of Mahout is completely for machine learning. Somebody says, I want to do something with k-means, with k-NN, or I want to do something with support vector mission. There you're looking for a machine learning library. So there the solution would be Mahout, right? Okay. So the advantage of Hadoop was very simple. Hadoop said that I will give you applications which can be scalable. It can be used by 10 users, 20 users, 100,000 users. Still, the environment will remain the same. And most important, as I said, no, you are not going for investing on the hardware. You still use the same computer and same server, but you do Hadoop, right? And Hadoop has got the capability of fault tolerance. What is fault tolerances? If any of the user in the cloud as part of Hadoop is getting lost means the network is lost, automatically Hadoop will intelligently share the response to the remaining users. Let's take we are 5 users in the cloud, right? One of the user, let's take my network system is temporarily down. There was a computing that was happening with the 5 systems. So what happens is this computing will be shared to the remaining 4 people and it will be completed. And assume that I'm coming back again to the network, right? Then automatically I will be given some part of computing and the entire task will complete. So this is the advantage of cloud, which people should understand. The advantage of cloud versus distributed computing is distributed computing do not have the capability of intelligently sharing the load when systems are offline. Systems are offline means if any of the user in the network is going out of the network in a distributed model, the distributed model does not know how to share the load when the system comes back, right? But cloud is not like that. Cloud has the capability saying that if any of the user is out of the network, the load will be shared among the other users. And once a user comes back to the network, right, network error is corrected, the user is again back to the network, the load will be shared again from where the user left. So this is not there in distributed computing. Okay. Now, if you look at this overall hierarchy of Hadoop, you can see very well that Hadoop actually has applications which are running based on Java. So you have a JVM, which is Java Virtual Machine, and it has a data storage framework which is called as HDFS, which is Hadoop Distributed File System. And the data processing framework will be done by using the MapReduce. We'll discuss all this. This data access framework actually has algorithms which are provided as part of different programming languages. So which is Pick, Hive, Scoop, and next is Apple, right? And with respect to the data orientation part, you have got HBase, Chakwa, Flum, and next is Zookeeper. Right? Now what you need to understand is if I have some data, I can intelligently process the data by writing some programs using Hadoop. Because the Hadoop gives me two important things. One, as part of storage, it gives me the concept of HDFS, which is Hadoop Distributed File System. And as part of processing, it gives me something called as MapReduce. Okay. Now, when you look at the Hadoop concept, the Hadoop will say that there is something called as a master, there's something called as a slave. What is this master and slave? It is resembling the concept of server and client. You can have one server, you call it as a master. The rest of them becomes a clients. Similarly here, you can configure any one of the node as a master and all of the nodes can become the slave, right? So the master nodes as such will keep track of the slave nodes. For example, I want to process 100 records. I can distribute this 100 records to the 5 nodes, which I will call it as a slave nodes. So every slave node will have something called as a task tracker, which will be giving me some sort of response, right? Which is saying that how the nodes are completing the task, right? And coming to the programming part in Hadoop, you can write your programs in Java, but still Python libraries are also available for you to work with Hadoop. Now let's look at this here. If you look at the entire scenario in Hadoop, you are actually having nodes, right? The nodes as such can be called as a slave nodes, and the slave nodes will work with the master nodes. So Hadoop has Hadoop distributed file system, and when you look at Hadoop distributed file system, it says that the block size of the data that you're processing will be with size of 64 MB.
Sir, are you changing the slides? Actually, we can see.
You're seeing which slide, sir?
Sir, incentivizing data exchange and AI model exchange. That is what we can see.
Okay, one second. I'll share again.
This is slide number 26 out of 33.
1 minute. Where are we right now? I'm talking to you on Hadoop. Are you able to see the screen?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yeah. So what I was talking to you would be is like the understanding of Hadoop. So the universal thought is very simple. You can use Hadoop for building cloud applications. Hadoop has a concept of HDFS, which is Hadoop Distributed File System. And when you talk about nodes in the Hadoop, one node will call itself as a server, which is a master node, and the rest of the nodes can be called as slave node. So the master node will allocate the task to the slave nodes, and the slave nodes can do the task and come back with a response. One second.
It is following the same topology or working architecture of Bluetooth, where we have master and slave.
Yeah, but actually there you talk about channel allocation, signal allocation for algorithms. But here we talk about data and process allocation to the users.
Okay.
Yeah. Are you now seeing a change in slide where I'm showing a diagram? Just I'm confirming. Hello?
So we are at slide number 26 out of 33. We can see slide number 26.
My question is, are you able to see the diagram where we are showing the switch and master nodes, secondary nodes?
No, sir.
No, sir. No, sir.
One second. I'm sharing the entire screen. Where are we going lost? Now are you seeing the diagram?
Yeah.
Yes, sir.
Thank you for saying okay. Now what I was trying to say is like you will have something called as master node and slave node. So every nodes will have a name which will be calling itself as a name node just for identification within the network. There will be a job tracker program which will track the status of the programs which is running on the slave nodes. You can have secondary name node also, and you can call rest of the nodes as client nodes, right? Now I am changing the slide. Are you seeing the next slide with Hadoop distributed file system?
Yes, sir.
Okay, thank you. So I hope we are on right. Okay, so as we said, we are trying to use Hadoop. So we have Hadoop distributed file system, and Hadoop distributed file system will say that the block size that you can have for the data can be in terms of MB. So the largest block size will be of 64 MB. So now the first we talk about the name node. The name node as such will be having the first indication of a node in a network as far as cloud is concerned. So the server which is holding the name node will be only one, right? Because there's going to be only one master node and rest of them are going to be slave nodes, right? And wherever there's a name node working together, then the next one is called as a data node. So the purpose of data node is to store the actual data in HDFS, right? So whenever the data node is getting updated, automatically it will inform the name node of what type of data it has, right? So it is generally theoretically understood saying that the name node will replicate block size of 2x in local rack and 1x everywhere. What is this local rack and other network components we are trying to talk about is? You see this diagram here. You can see here, these are understood as racks, rack 1 to rack here, right? So each of the racks, you can say that you have name node, you have job tracker, you have secondary node, you have client, you've got rest of the racks. So the same thing we are trying to put here in terms of rack keyword. So don't confuse in the learning part. So name node will replicate the blocks 2x in local rack and 1x everywhere. Okay. This is what actually happens with respect to the map reduce concept. Anytime you are giving a data, the data is going to come as a file, right? Just now we saw, no? We created a CSV file for understanding persons in a building. So this input file will be split, will be given to the first component, which is called as a map, right? So the second component that it will get created is called as reduce. So the mapper part will work with the reducer part, mapper, reducer. Now this is going to work as part of the client requirement. So the client wants to do some task. So that task will be done by using the map reduce operation, right? So once the result of the mapper is complete, it will be given to the reducer. So the reducer as such will do a reduce operation, map operation, reduce operation, right? Okay. Now it will give you the final output. Now there can be multiple map reduce programs which are running, but every time you will have a mapper working with the reducer part. So a client wants to complete a task, the client gives a request onto the cloud. The cloud with respect to Hadoop will have a mapper and a reducer to work together. This cloud infrastructure can actually work within the same building or it can be demographically at different places. So you can assume that the map reducer is running in different nodes as part of the network which is established demographically at different places. So when you look at the nodes, as we told you, we have many number of data nodes. All the data nodes can actually be part of a rack, right? So what is a data node? A data node is one which actually does the processing, and the data node will store and process the data using HDFS, that is Hadoop distributed file system. A client is requesting for an operation. A client will interact with the data node, and the data node can be any one of the data nodes. Now, when you talk about Hadoop, the data that you're trying to process will be replicated across the nodes, right? For example, if I have a data in node 1, the same data will be replicated across the nodes. Reason is, if any one of the node goes to a failure, then automatically the data will be processed by the remaining nodes, right? And as general, you do with any file handling, you have read operations, and your name node will actually have a metadata. What will be there in the metadata is it will have the name of the cluster that it is processing, and second, it will try to have the replicas of the data. So MapReduce engine that we talk about here has two things. One is called as job tracker and next is called as task tracker. What a job tracker will do is a job tracker will split the data into smaller tasks, right, which is called as map, and then it will actually send it to the task tracker. The task tracker will report back to the job tracker on the progress by completing the reduce operation. So the understanding would be is very simple. A job tracker will have the map and job task tracker will have the reduce. Okay. And when you look at these architectures have improved a lot. Now we do not have the concept of Hadoop directly. We have it as Spark. Hadoop exists, please understand. Hadoop still exists on the internet for configuration and deployment, but now what we have more intelligently is something called a Spark. What is the advantage of Spark is, Spark has Hadoop by default. When you say you are using Spark, it means that you are actually using Hadoop also. And second thing with respect to Spark is, Spark has got more operations in comparison to Hadoop. Hadoop has got map and reduce. Right. Similarly, when you come to the Spark, the Spark has got map, reduce, and next is shuffle. Now, if you ask a question, which are the users of Hadoop? You can see here the users are the big players on the internet, which can be Yahoo, Amazon, Netflix. All of them use this Hadoop framework. So there are three main applications that are generally suggested for using Hadoop with respect to cloud. First one is wherever you want to build some sort of recommendation systems. Like for you are going to Flipkart and searching for a product, they are suggesting a product, plus they are recommending who are the possible vendors from which you can purchase with the user reviews. That is an example of advertisement scenario. The second one is searches. For example, if you go to the Google search engine and you are trying to type for a keyword, it gives you the possible documents where the content is available. That's an example of a search. Third is security. What is security is like, you want to actually find the possible patterns of the data. Even a password guessing is also an example of a security challenge here. So there you can actually use Hadoop. When you look at the real-time data set, that's one side. When you look at the non-real-time data set, that means you are looking at offline data which can be processed. So there also you can use Hadoop. Example of this is actually all the document image processing. So the design requirements are very simple. You are interested to use Hadoop by trying to minimize what the user wants, right? Whenever the user is asking for a data, you want to provide the data for the user with the least amount of time, right? So this is the small introduction to Hadoop. Now with this, we'll go to an example for working with Hadoop. Now I'll share the screen again. Just clarify me if you are able to see correctly. Yes. Participants, are you able to see my slide on MapReduce?
Yes.
Yeah, okay. Thank you. Now what we'll walk through is like how MapReduce can be taken for an example and how you can integrate it to the cloud scenario. We have just now summarized saying that Hadoop uses concept of MapReduce. Map is an operation which is part of mapper, and reduce is an operation which is part of reducer. So any task the user wants to complete can give it to the Hadoop. The Hadoop will take the help of map and reduce to complete the task. So this has been used in many countries all over the world, right? Okay. So one example that is shown here is in Canada, where they want to see how much the flu has spread over the years, right? So that has been experimented by using MapReduce. Right. Why do we need MapReduce? As we have discussed again and again, the answer is very simple. One computer cannot process the entire data. You need a distributed system which needs to store or process the data in parallel, right? If you want to do a parallel programming, there, as I told you, threading is very hard. Threading means, I think each one of you know, you assume a process as part of a thread context. Within the thread, there can be a data which can be processed. But when you run multiple threads together, it is a common problem thread. Which thread will hand over the task to which other thread? So when you increase the number of computers, parallel programming with threading is very hard. Second thing, which I told you already in summary, the difference between the cloud and the distributed computing is. Whenever the system is undergoing a failure, like a system is leaving a network, joining a network, their parallel programming or distributed computing cannot handle such scenarios. There, the answer was you need a solution for it. It was provided by using the cloud. So a cloud provided the MapReduce, which said that I can automatically parallelize the task, I can automatically distribute the task across the users. And as I told you, the systems are going through a failure. They are leaving the network. That will be recognized when you are using the concept of MapReduce. Right? The next important thing is you cannot increase the number of servers every time. You need algorithms which can efficiently manage the data. There the solution was we can go through the concept of MapReduce. Okay. So when you look at MapReduce, what the MapReduce will say is, you give me some data. First step what I'll do is I'll just split the data. Participants, please listen. Very important. It will give you an insight about how you can model your data, right? So first it says that you can actually split your data. So when you want to split your data, how will you say? You will split your data as chunks of data, right? Are you able to see my slide, MapReduce workflow? Participants?
Yes, sir.
Yes, sir.
Yeah, fine. So this is your input data. This data is split into chunks. So you say split 0, split 1, split 2, right? So that is a mapper. That will be a reducer. So the purpose of mapper will supposed to extract something, what you want from every data, right? So it's a read operation. Now it does a local write. That means to the local nodes, it writes the data. Now once it writes, then automatically a reduce operation will happen. A reduce operation can actually use an aggregate, summarize, filter, or transform. Now, if you look at this keyword, people get new doubts. Okay, what are we trying to say? For example, if you talk about summarize, it's equal to a group by operation that you do in the SQL query, right? Okay. So once a map works, then automatically a reducer can work. So the reducer as such will write the output to the file. So what has happened in this process is a data which was like this is processed by using the mapper and reducer, and it is written to an output file. Now this output file is the data which will be answering to what the user wants, right? Okay, so that is the purpose of MapReduce. So a MapReduce in summary will actually read the data, provide it to the map, then it will do a set of operations using reduce, which can be aggregate, summarize, filter or transform, and it will write to an output file. Now let's look at an example for this. If you have an input file like this, which has got names of fruits, right? The files are more than one. Okay. Now what we do is we are trying to give it to a mapper. So what the mapper is supposed to do is it is supposed to have the file data read. So it reads as apple, orange, mango. The second row is orange, grapes, plums. This is apple, plum, mango, apple, apple, plum. Now it actually does a splitting. What it means by splitting is it will try to give instance for count of the data. So apple is 1, okay, orange 1, then mango is 1. Similarly here, orange 1, grapes 1, plum is 1, right? Similarly here for every word, it gives a number 1, okay. So here what has completed is a mapper has given a key. So the purpose of a mapper will give you a key value, right? So now it gives to the reducer. Now before it gives to the reducer, as we told you, it has got concept of sort and shuffle. So what is sort and shuffle? Just now we have seen here. You can see here there's a sort, there's a shuffle operation that you can use. Now what a sort and shuffle will do is it will try to shuffle the data. How it will shuffle the data? It look at all this data as single data. So apple, okay, wherever apple is occurred, okay, apple 1, fine, then apple 1, then apple 1, then apple. Similarly, orange, if you talk about orange is 1, okay, fine. Next, orange 1. Similarly, mango is occurred here, 1, 1. Similarly, plum, comma 1, plum, comma 1. And there's one more one, plum, comma 1. So 3. Right, okay. Once it is provided that, then the next is like it goes to the reduce. Now map operation is complete. It goes to the reduce. What reduce will do is reduce will try to do an aggregate. It can be a sum. It can be a group by, for example. So apple, how many types? 4 types. Grapes, 1. Mango, 2. Orange, 2. Plum is 3. So the final output will be like it says apple 4, grapes 1, or mango 2, orange 2, plum 3. Now if the user C plus 1 second. Sorry. Yeah. So what has happened is the result of map is given to shuffle, and then we have a reduce. So now if the user is asking a question, how many apples are there in my file? It will give me an output as apple 4. How many oranges are there? Oranges 2 in the file. Now, if we do not have a concept of map reduce, what happened is this is files will be given to a program. The program will have a word count program. The word count program will give the output. But every time when you want to process, you have to go to the file, run through the word count program and do it. But what MapReduce said is, based on the type of request that will come from the user, you write a program using MapReduce, process the data and keep it. When the user is requesting something from the data, the processed file from MapReduce will give you the output. So here, somebody will immediately ask a question. Is it basically dependent on the data? What I should process? Yes. Here we are showing a word count. If it is going to be a data with respect to customer sales, it will be basically with respect to the sales data of the customers. Okay. Are you? Yes.
I have a question for the previous slide.
Yes, sir.
Sir, in the input splits, if there is a repetition of the same item, will the mapper do an aggregation on that input split also? Here in the last input split, we have 2 apples. So is it possible that it will aggregate it as apple, 2?
No, it will not do that. Actually, Mapper doesn't have capability of doing any aggregation, any operation on the data. What it does is it gives a key value for every data that you are getting.
So the value is always 1 as
Yes.
far as the mapper is concerned.
Yeah, in terms of the word count program, I show you another example also. In terms of word count, it is 1 because you are looking at the occurrence of words.
Okay, thank you, sir.
Yeah, thank you. Now I go on to the next slide. I think you're able to see it, right? So you have an Hadoop program. So what the Hadoop program is supposed to do is it's supposed to run on the master node. The master node will aggregate the request to the worker nodes, which is a slave nodes. So slave nodes will do the process and they will come back by running through a map and reduce operation. So the resultant of map and reduce operation will be conveyed back to the master node. So what you get is an input data which is processed as an understandable output data, as you can see on the right side. This is happening because you have a Hadoop program running, right? So the amount of data that you can process, since it is processed data, so your original size of the data will get reduced. So you can have larger amount of data processed by your slave nodes. So that is where Hadoop said that you can actually use this concept everywhere. So in line we have got a Google file system which is GFS. We have an Hadoop distributed file system which is called as HDFS. So as you can see here, the input data is distributed right across the servers. So it is not only one master node, it is across master servers if it is in the internet community. So when you take a map reduce and you're giving the data, now the question is like, where is the chunks of the input data? These chunks of the input data are actually mapped to the slave nodes, right? So worker node gets split 0, worker 2 gets split 1, worker 3 is split 2, because this is my original data and splitting it as chunks, right? So each of the worker node will actually process and they will try to give it to the reduce operation, and the reducer will actually write the output to the output file. Now this is where I was saying, if any of this worker node fails, then automatically this master node will give the input that the node is failed, and it will reassign the task to the other worker nodes. For example, this worker node fails. It is already provided with this data, which is chunk 2, which is split 1. So automatically the master node will reassign the data and the task to the other worker nodes. This will intelligently happen because the Hadoop design is like that. The Hadoop by design can actually know which nodes have failed and reassign the task to the other nodes. So as I told you, there's a failure, automatically it will re-execute the task. So here the failure might happen at 2 levels. One is the master node and next is a slave node. If the master node is going to fail, it will restart and it will reassign the task. That means the master node will restart and will reassign the task. For example, if the master node is failing, it will reassign the task once it comes up to the worker nodes. But if the worker node fails, as I told you, the master node will coordinate the task with the other worker nodes. So it is said that it is very robust. In fact, Google says that it is still successfully running. So this is a part of the code for the master node, where it actually has a mapper and reducer which will run on the slave nodes. So as you can see here, no, this is a mapper code, this is a reducer code. And when you look at a Java program perspective, you know that this is one individual class, this is another individual class, right? So this is map, this is reduce class. So you can make an instance of that by assigning it to a job, right? And then you can run the results. Now what we will see is a small example to understand this map reduce. Okay. Now I am stopped sharing. I'll again open the notepad file. Just clarify me whether you are able to see. Okay. Are you able to see a text file?
Yes, sir.
Yes, sir.
Okay, fine. Now here, we take first one example, which we all know, right? Let's take, we have students mark data. Fine. Okay. Now, as I told you, the principle of reduce is, it says what the user wants based on that the reduce operation will work. Now let's take you, if I ask somebody, right, what sort of data will you try to answer from a student marks? What would be your questions you would ask? Can anyone give a question? Hello. Given a student mark data, what questions you will ask from the student mark data? Participants?
The average marks.
Okay, so give me the average mark for a subject or for a class map?
For a subject.
For a subject, okay. Okay. Fine. Any other question? Participants?
How many students have failed in the subject?
Okay. Yes, subject. Okay. Any other question?
How many students have passed in a subject?
Okay. How many students have passed?
Have passed in a subject.
Okay. Fine. Now let's look at the student mark data. Right. Now I have the student mark data like this. It says roll number. I got 5 subjects. Okay. And 3 and 4 and 5. Okay. So roll number 1, 34, 56, 67, 78, 89, 45, 52, 63, 78. I'm just giving random marks. 86, 78, 89, 90, 92. Roll number 4, 45, 78, 89, 91, 96. Roll number 5, 52, 78, 90, 92, 96. Okay, this is an understandable data for everybody. Now let's come down to what map will do. So the purpose of map is supposed to give us a key value pair. Okay, fine. So I'm talking about the individual data. So first what I will do is like with respect to roll number 1. For example, if somebody is asking for a key value pair, they will say M1 34, okay, then M2 56, okay, M3 is 67, M4 is 78, M5 is 89. Okay, if you want to have it more meaningful, you can use this symbol also. M3 is 67, M4 is 78, M5 is 89. This is for first roll number, right? So what is key here? Key is marks, that's the subject name. Value is what value you get. So I'm just fine. Now I just go and change the values. For second row is 45. What is 52? Participants, you can also support with the answer 63. This will be 78. This will be 90. Okay, what about third student? Can you give me the answer? M1 is participants.
56.
Okay, good. M2.
78,
78. Okay. M3.
89,
89. M4.
90, 90,
Okay. M5.
92,
Okay. This my fourth student.
45,
45.
78,
Okay.
89,
Okay.
91,
Okay.
96,
Okay. The student. 52.
78,
Okay.
90,
Okay.
90,
92,
Then,
96.
yeah. So now what we have represented is we have made the data meaningfully as key value pair. Now the question is like we need to do some reduce, right? Now as we said, we can actually do the mapper. Once at the mapper is done, we can split the data also, right? But before that, let's see what is the reduce part. Come to the reduce part. Reducer is actually dependent on what the operations you want. What is the operations you want? First question the user is asking is, give me the average mark for a subject, right? That means I should subject wise a mark. Okay, I should store the subject wise mark. So what I should do is before I give it to the reduce, right? My file data should be converted, right? For finding the average mark for a subject. So how it should come? It should come as M1. What are the values for M1? Can anybody say? 34? Participants?
56,
45?
45, 56, 45, 52.
45 and 52. Thank you. So like this, you should actually take for all the subjects. M2 is 56.
52, 78, 78, 78,
M3
67,
67,
63,
63,
89,
89,
89,
90. M4 78,
78,
78,
90,
90,
91, 92,
91,
92.
92. Good.
Sir,
Fine.
here M4 1 second, sir. M4 78, comma.
Yeah, correct. Thank you. M5 89, 90,
90, 92,
92,
96,
96,
96.
96. Okay. Now, if I ask you for the first question, what is the average mark for a subject, right? What operation you need to use for average of a subject? Participants,
Sum of the
Sum
numbers divided by the
Sum
count
of the
the
numbers divided by 5.
yeah, correct. That's it. So you would actually say, for the first one, I will use an average function. So you will write an average function under reduce. So there you will say, you will find the sum of marks for your subject, right? Divided by, is it clear?
Yes.
If you look at the output file, what will be there in the output file? It will say M1 average value. Let's take, I'm giving it as AVJ1. What is AVJ1? Average of M1 marks. Yeah, correct. Then what will be in the output file? Similarly, for M2, you'll get an average. Let me indicate it as AVG2. M3, you'll get an average. So it will be AVG3. M4, you'll get an average. It will be AVG4. M5, you'll get an average. It will be AVG5. Is it okay? Now, this is output file. Now, once the user is hitting a question, give me the average mark for a subject, where you say, where subject is M2, then automatically this output file give the answer, okay, M2 average is this. So you're not going back to the original file, right? Your process a file and kept, but the reduce operation is dependent on what the user wants in the question. Now, if the second question, how many students have failed in a subject? Is it clear? How many students have failed in a subject? So that case, before I go to reduce, okay, I can actually see the data and ask, can I actually say how many students have failed? So if you want to know the students failing, one answer is I can actually give a condition saying if it is 45 marks, it is failed. Are we getting? If it is 45 marks, it is failed. So there you have to use your reduce function, which is your user defined function. So I'm writing a function for fail. I will say within the fail function, anybody who is greater than 45, right, is failed. Are we getting? So that case, in this
Less than.
in this output file, the output file will actually get processed only when I have an intermediate reduce. So what will be there in the intermediate reduce? It will actually check for every subject. M1 greater than 45 is failed. That means what? Here it is 1. I think people can understand because this is matching. Participants, I think you can understand. Greater than 45 is failed. So this person is what? Sorry, not greater than 40. Okay, we will keep it as less than 45. Sorry. So 34 is what? Less than 45. It is failed. What about 45? Passed. Yeah. 56? Passed.
Pass.
45?
Pass.
Passed.
62 pass.
Okay. Now, what function will you use to say how many people have failed?
We get sum.
Yeah, good. So you will find a sum. So once you apply a sum, it will say for M1, the sum is what? How many people have failed? 2 people have failed. Hope you are getting, right? So if you have a question saying how many students have failed in a subject, if it is M1, you will be able to get. Similarly, for you will actually do for M2, M3, M4, M5 and keep it in the intermediate part for completing the reduce operation. Participants, is it clear?
Yes, sir.
So please make a summary in your learning always. When you want to do a reduce operation, before you do the reduce, first you have to ask what questions you want to have from the data. Based on that, you have to build your data and keep it for intermediate part. But please always understand, map will generate only key value pair. Map will not do any functional operation. In the reduce, you can use your functional operation, which can be average, minimum, maximum, or you should write your customized function, which will actually process the data and keep it, so that you are able to answer to the user's question. Right. So that's it from my side. So I hope we have learned the concepts. So in summary, what the discussion was about how IoT can be taken from the cloud perspective. The second discussion we were interested in knowing is how to process the data in cloud. So the MapReduce is a solution. I've shown you two examples. One example that you saw earlier was a word count problem. Again, the same thing I've shifted for a student mark application. Now, this can be taken for a variety of examples. Suppose you're talking about the customer sales. So what you will have for every customer, you will have the sales of the product. You can ask what questions you can ask against the product. Based on that, you can build your reduce operation, right? And if there's a question, okay, I also want to do something like this. Will I be able to do it from application perspective? Yes. All you need to do is you have to spend some time to understand installation of Hadoop. Then you will have to spend some time to do some programming with Python or Java. Anyone is possible, right? And today you've got a lot of working codes on the internet. And visualization is also possible because the Python libraries are there for you to do good visualization. All you need is a good data for you to process. So there's a lot of data available. One data which I would suggest is, as I told you another day, you can go to Kaggle. There you get a lot of data sets. You go to Kaggle and type IoT data, you'll get a lot of data sets. So you can understand what the data is, and from there you can actually do your research, or if it is a project, you can implement it as a project. And if you're looking for a grant, then I usually suggest this link. You have NVIDIA grant. Okay, there's a grant which is open from NVIDIA. It's open throughout the year. So there you can take a small working idea, which is having big data. You can write it as a small proposal. They'll give you graphic cards free of cost. Right? You can see here, no? Next window is opening in January 2022. You can apply, you will get graphic cards with which you can write programs, run it and keep it for your understanding, or you can take it for your research also. So that's it from my side, and thank you so much for the opportunity provided. I've shared my email ID in the chat box. So if there's any questions later also, please drop me a mail, or if there's any common of interest which you want to work with me, or you have a problem where I can work with you, openness is there from my side. So learning is from everywhere, right? That's it, and thank you so much. Any questions from your side? Participants? Hello? Yeah, I put the email ID in the chat box.
So thank you for the wonderful session, sir.
Thank you.
Your explanations were so down to earth with the numerical examples. You were able to catch the concept easily, sir. And I had just one question.
Yes.
Can you just tell us some details about how to take the data from Kaggle and ingest it into a Hadoop system?
Okay, fine. See, you take any data on Kaggle. For example, I just take your data, no? For example, there's a data on IoT sensors. Are you able to see the screen now?
Yes,
No.
sir.
Right. This is a Kaggle data, right? Now, if you look at this data, that'll be, so let's take some data sets. Okay, this is your data set, for example, and you want to do some processing on the data set. So this data set, as it says, there's a downloadable data set in a CSV format. So you can create all you need to do is you need to go to Kaggle, create a login for yourself and download the data set, right? So once you have downloaded the data set, there will be an information about the data set, which will be really provided. This says this data set is collected with respect to different cities and so on. And you take the data set will actually give you some summary about how many columns is there. So this columns actually speaks about the features, right? So if this says it has got 659 columns. Sometimes the data will have class labels. That means this is a classified data set. If you have a class label for the data set, you will see it in the last column of the data. The class label is indicating whether it's a 2 class, 3 class, for example, or it is a n class problem. If you do not have a class label, then in that case, what I suggest to people is you take a program which is there in k-means, right? Algorithm. You run the program on the given data. It will classify the data, right? It classifies it into 2 classes normally. So once your data is classified, then you really have something to do with your testing. So as I told you, if you've got a certain number of records, as you can see here, no? you have a data set which is size 20.28 MB. Now, if you download the records, right, if there are 100,000 records, take 70% of the records and give it to the k-means, it will give you class label. Then after that, what you can do is you can run through an algorithm which is on the remaining 30%, and you can take the test values. The test values, what I'm talking about here is the performance measures. So if you go to the browser and you type performance measures, the common performance measure is the precision. So I'm just typing precision here. So if I type performance measure and precision, it will give you what is the measure. So please go through that measures. Precision, recall, accuracy, F1 score. But whatever may be the measure, no, whatever may be the algorithm you're using, it can be machine learning, deep learning, transfer learning. Your expectation is very simple. You want to reduce the number of false positives. Right? If your algorithm is able to reduce the number of false positives, irrespective of the algorithm trend, for example, I'm using the oldest a priori, I got less number of false positives, my algorithm is the best. Right? That should be your answer from your side, right? Then the last question you are asking is like, okay, I want to integrate it on the cloud, right? So there, if you go, you have codes where you can integrate the code. For example, if I want to run your k-means algorithm of cloud, so if you go to internet and type hadoop and k-means clustering, you will get codes as you can see here, right? Where they would have pushed the code on k-means clustering on a data set. Right? There you can take your data set and you can push your data set. For example, here there's a k-means code and there's a data set that they've used. Right? You can use your data set and push it here. Has that answered to your question, ma'am?
Yes, sir. Thank you. Thank you so much, sir. It's very useful, sir. Thank you.
Yeah, thank you. Thank you so much. Nothing stops from learning. Even after this, you can reach me in mail, and if you happen to work on some similar problems, I'll share you some working codes that I have with my team. You can use that codes also for running a quick demo, and from there you can increase your problem complexity and work.
Yes, sir. Thank you. Sure, sir. Thank you.
Thank you. Thank you so much. Thank you all. Sir, thank you from my side. To the organizer side, my sincere thanks for the opportunity provided.
Thank you, Professor, for the wonderful session. It was a highly interactive session. So we are very happy that morning session was very useful to most of them. So it is really an excellent session, sir. Thank you very much for your sparing your valuable time with us and accepted our invitation to be a part of the FDP, sir. Thank you, sir.
Thank you. Thank you. Pleasure. Stay safe, all of you. Thank you all. Good day forward. Thank you, sir. Thank you. I'll leave here.
Thank you. Thank you, sir. Dear participants, next session, resource person has already joined here.
Hello.
Sir, we start, sir.
Start. First, I want to share the screen, if you don't mind. Huh?
Yes, please. Yes, please, sir. Like to introduce, then you can start, sir.
Is it visible?
Yes, sir.
Yes, sir. It is visible.
Okay, nice. Please.
Sir, after the introduction, please switch on your turn on your camera for a while, sir. Then for a snapshot, then you can as you wish, sir.
Okay, because
then it's your choice, sir.
I just hold on.
Okay, good morning, participants. Welcome back. So actually, the second session, there is no gap in the morning session. So it is maybe a tight schedule also. So sorry for the inconvenience. So actually, second session is about IIoT, Industrial Internet of Things. The resource person is Professor Dr. N.K. Karthikeyan. At present, he is working as a professor and a head Information Technology Department and Coimbatore Institute of Technology called the CIT and Coimbatore. And he completed his BE in ECE from Congo Engineering College, and he did his ME at Computer Science Engineering in Congo Engineering College, and did his PhD in Information and Communication Engineering from Anna University, Chennai. Actually, he has, under his guidance, 8 scholars has completed their PhDs, including myself. I am one of the lucky person to have completed PhD under his guidance. And at present, 9 scholars are pursuing their PhD. And as a consultancy project, he has completed one AICTE RPS funded project, namely environmental monitoring system using WSN and its implementation in the year 2012. And he has published a number of papers and participated in a lot of conferences in national and international levels. And his responsibilities for a number of engineering colleges and engineering colleges. For a few, I will mention. He is a Anna University nominee in the Academic Council of Seth Institute of Technology, Madurai. He is a member board of studies for computer science, engineering, and information technology branches in SNS College of Engineering, Coimbatore, and Dr. Mahalingam College of Engineering, Pollachi, and Nanda College of Engineering, Europe. He is also a management committee member for Computer Society of India, Coimbatore chapter. He is a vice president, Innovation Cell and CIT Coimbatore, and he is member in Econs Degree Committee in DOT and TNHE in the year 2019-20. He is a member in various professional bodies like ISTE, CSI, and ACM. His thesis, one of his thesis called the System for Detection of Leukemia using Hidden Markov Model and Adaptive Neuropathy Inference System has been applied for patent. He is applied for patent along with Dr. M. Sangeeta. And he has been chaired in a number of conferences and international conferences. And he is a reviewer of many journals like Elsewhere, IST Journal of Research, Information Sciences, InterScience, International Journal of Computer Intelligence System, and technical committee members of various international conferences. His profile is very long, so I have, due to time short, I have cut short of many of things. Kindly excuse me, Professor. And on behalf of institution, I personally welcome for the FTP and to present a session on IIoT. Now I hand over the session to Dr. N.K. Karthikeyan.
Thank you very much, Professor. It is my immense pleasure to talk on industrial IoT. And at this juncture, I have to extend my sincere gratitude to the Shakti Polytechnic management and in-person HOD for arranging this sort of faculty development program for the betterment of faculty as well as the students. I think let me first give away the introduction about industrial IoT and why we go for this. So I think this particular session definitely will give, you have to have a knowledge on why we go for IoT and in particular industrial IoT. My dear faculty members, for your information, just 2 years ago, AICTE have identified some 5 to 6 technologies wherein all the faculty and the students belonging to the AICTE should have the knowledge on all those 5 technologies. And in that particular domain, very interestingly, your IoT, because the artificial intelligence, big data, cloud computing, data analytics, IoT, and other are in the forum to be introduced to all the faculty and students community of our AICTE institutions. So let me give an overview, because I am not fully deal with all the your data analytics, etc., etc. This is just an overview, so that as a first part you have to have some knowledge on your industrial IoT. And let me first give the agenda of my presentation. I have to talk about what is IoT, why it is so significant as of now. And second one is, what is the role of your sensor technology as on date? And the next, cloud technology. As I already told, these are all the very embedded one for our today's latest state of the technology, cloud technology, big data. And finally, I have to give away the industrial IoT stuff, and the conventional way we have to have the knowledge on SCADA. I think most of the all electrical, electronics, computing engineers earlier have some knowledge on SCADA, but today that is mostly replaced by IIoT. And definitely my last is I have to give some concluding part why we go for this particular technology as of now. Okay, so I have to start my presentation with very fundamentally, I have to start with microprocessor. Dear my faculty and the student friends, the evolution towards our computing technology. So from my perspective, I viewed the evolution starts from your basic 8-bit microprocessor. All of you are aware that. Okay. And next, we are in a position to go for some application parts. Yes, for computational purpose, we have to have the microprocessor technology. But with respect to our today's application part, for example, even I used to tell to my students, microcontrollers. Why we go for microcontroller? It is nothing but some specific application we have to have from microcontroller. So the microprocessor is a general purpose. Yes, for computational processing, etc., we are doing things for microprocessor, but slightly there is some demarcation pertaining to your microcontroller, wherein, for example, you want to measure, right, the water level in your sump or in your well. In that case, we go for some specific microcontroller chips. So we have to incorporate it thanks to your microcontroller technology. And the third phase, the embedded system is very, very important. So embedding is nothing but both hardware part as well as software part with more computational part. Because here the microcontroller is for some specific application only, whereas embedded systems is far more oriented towards the bulkiness and heavy data operation. So naturally, the embedded system is the result of that. Accordingly, parallelly, there is another technology, right? SCADA technology. I think most of you come across it, and most of the industrial purpose we used SCADA, that was the past or history, but that could be replaced as of now by IIoT today. So it is my humble request to all of you, please listen carefully the various phases of your IoT stuff. And this particular slide, I used to tell to my faculty members, please have some knowledge on Gartner Research Group. Why? Because the Gartner Research Group is an autonomous body which is used to the technology to forecast within another 5 years what could be the output or what could be the products or services from our information technology and allied fields. So the particular Gartner Research Group findings in August 2014, they forecasted in 2014 and 15 itself, your IoT play a very vital role in another 5 to 7 years. Yes, now we are witnessing. So the IoT and parallelly IIoT now, the Taraga Mantra of our today's technology, not only the mechanical oriented, almost all sort of technology. So it is my profound duty, right? So what is IoT? I think some of you may be familiar with this, but my aim is to familiarize IoT as well as IIoT to all the faculty and students, those who are attending this particular session. So from my perspective, we are concentrating the main thing on IoT, that is nothing but communication. Yes, sir, the communication, earlier it was started well off with the telecommunication, connecting various right devices and from machine to man and man to machine, etc., etc. But in addition to that of our basic communication, we have to speak about thing, right? So here thing is nothing but anything you can find for that. Even I used my pen, which act as a thing. So if that pen is IP enabled, so I want to introduce the term called IP. It is also birthed from your internet. Okay. So the Internet of Things mainly concentrate on threefold. One is your communication part, and the second one is basic IP, and third one is to interconnect anything in this world. Okay. So the thing as of now become, so anything in this world that is going to be what we are witnessing in future, the pervasive computing. So pervasive means present everywhere. And this particular technological evolution, right, we should learn definitely. Why? Because from your data quest some 3 months back, I come across one article wherein with respect to IoT technology in India, almost for the last 2 to 3 years, even though we had the pandemic and corona, etc., threefold time increase in spending towards your IoT and allied products and services. So definitely, as our IT professionals, whether you belong to electrical, electronics, or computer science, or even mechanical, definitely we have to learn about this particular IoT, wherein the application, what we term it as use cases. My dear students and faculty, with respect to IoT, instead of application, they use the term called use cases also. Yes, now we are having use cases with respect to smart cities, healthcare. All of you come across that logistic with respect to your transport mechanism, retailing, safety and security. These are all the various use cases of your IoT. And the main thing of our technology trend have been witnessed from this particular PPT, wherein earlier we started off well with the technology such as your RFID, radio frequency identification tags, but as of now, we are viewed it in a very, very interesting phenomena thanks to our today's software agents and advanced sensor technology, which paved the way for the revolution towards your IIoT. So this particular terminology is used to IoT. Don't confuse with the other terminologies, because each one, for example, Cisco's favorite term for your IoT is nothing but IoE, that is Internet of Everything. In some companies, they termed it as Cloud of Things. And in some companies, they use the term called Web of Things. So don't worry, only slight demarcation among all those technological terms. Don't worry about that, but almost all are kind towards the same IoT concepts. And with respect to this particular slide will give away the today's cyber physical system, wherein the amalgamation of the various entities. Yes, we are dealing with data volume. My dear faculty, earlier we have to have limited volume of data only. Even I used to tell to my students, we have maybe KB or MB to at most GB, but as on date, pertaining to our multimedia technology and thanks to your social networking, wherein we are concentrating on betabyte, zettabyte, etc. So the voluminous of data is huge and huge. And at the same time, we are going for an advanced networking technology, because all of you are aware that if I speak the term called IoT, the fundamentally is our IP as well as your each unique IP address. I think all of you know that it is a very, very basic thing. And today, since we are applying all those new technologies to the top of our social media, we are having payback as well as your GPay, etc. So the security play a very vital role. So if I'm talking about security, automatically the reliability, precision, everything come into picture. And we have to talk about these three, any, okay? So anything I want to make communication, any place, there is no physical dispersion from one continent to another continent, and at any time, there is no restriction on 24/7, etc. So all those things could be possible thanks to our today's cyber physical social data system. So this is my personal PPT, wherein we have to concentrate all those things. So for simplicity, just give me some 2 to 3 minutes only for the emergence of sensor technology. Here we have to thank our electronics people, because with respect to sensor, basically the sensor from various materials, your material science department, and the emergence of sensors, not only the sensors with the high reliability due to its application in space as well as your defense and healthcare mechanism, sensors play a vital role with the high reliability and the cost. The success of your sensor technology, from my point, is lying with the top your cost, because any technology you are dealing with, any sort of technology and services that could be able to reach a common man, provided that could be offered at a very, very cost-effective way and simplicity. So that is the success of even I rated to your today's mobile phones. Even you can able to purchase a mobile phone at a cost of your 1,000 rupees or 1 lakh cost. So thanks to the sensor technology for that all those success, and these are some of the sensor devices for your information. I think today from A to Z application we have to have. Today, yes, due to this pandemic period, we used to pulse oximeter, and we are having temperature measurement, and for the sugar and other things we have to have for our body healthcare condition. We are using smartphone, etc., etc. All are enabled or embedded with the top of your sensors. So the success, as I already told, is mainly with the top of your cheapness of your sensor technology. And the very interesting point I want to tell about is low power connectivity. Even some of my research students are now working on the power optimization with respect to your sensor technology, and in particular WSN and body area network band. Okay, so the power is very, very important. If the power is high, definitely we are in the scarce resource of power. So naturally, we are in a position to go for some of the latest technologies which could facilitate consuming only low power. Even I used to tell the today technology, for example, is Bluetooth. So you are aware that we are in our mobile phones, we are using a Bluetooth technology where it consumes very, very low amount of power, even not in watt, it is microwatt only. Okay, and as of now, for your information, lot of research is going on BL Bluetooth low energy. Okay, so these sort of low power connectivity also facilitate the success of your IoT. And the next one is our fundamental mobile device technology, which could able to accommodate any sort of sensor devices, or that could be possible with embedded hardware part as well as software part, and thanks to your mobile devices and the portability of it. So these technologies are very important for the success of your IoT. And next, we have to talk about, I think Professor Senthil Kumar, my friend, has told about your other Google and other technologies pertaining to your big data, cloud computing, etc. And he has told about AWS, your Amazon Web Services, etc., etc. So the cloud computing is also the main factor of the success of your today's IIoT. Because earlier, with respect to your standalone only we used. For example, if I am using a particular software at CIT, that would be useful only for the people who are using that services at CIT alone. But let us assume the scenario, we have to have a lot of today's 5G technology as well as right other modern lathe and softwares we are now having. We now offering some cloud services to our local right lathe operators, etc., at a very low cost. Why? Thanks to your cloud computing, wherein if a particular lathe section near to Coimbatore, say Nilambur, they are having right some mini lathe shop and having or purchasing a new software may cost some 50 lakhs. Definitely, it is a huge investment. So it is not affordable for them, even the small scale industries and medium scale industries. So at this juncture, they can go for some sort of cloud sharing. So if you have some sort of MOU with the CIT, for example, we are offering some cloud services to them in the form of sharing of both hardware and software. I think you all aware about NAS, PaaS, right? Platform as a service, network as a service, software as a service, etc., etc. But due to time limitation, I cut short all those things. But however, we have to thank, right, the cloud platform offered by our cloud service providers, like that of our cell phone service providers, right? Various cloud service providers are also now coming in a big way. Even some of my alumni students are now in the business of startup of offering cloud services to small scale industries and medium scale industries. So my dear faculty members, finally, so this is what we had, okay? So any people or any person could be able to make use of the IoT technology. It is just a glimpse of how a healthcare mechanism can be incorporated and helpful to a human being. So a human being who is on a walk on a particular, right, let us assume at Coimbatore racecourse, he or she is making some, right, walking or jogging, all those sensors have been embedded into his body, and it could be possible all the movement, his body condition like temperature, pressure, etc., etc., even his right number of steps on that particular day, his movement have been governed from remote. Thanks to your internet, cloud, and all those healthcare operators, even from home, his family members could be able to, right, connect, and they can able to visualize the movement of his at racecourse Coimbatore, as well as his body condition, as electrocardiogram, as well as his heartbeat rate, etc., etc. And that could be possible even with your cloud services offered by companies and as well as healthcare like KMCH or KG. Okay, so this gives a glimpse of what could be the nature, and I am very proud to say that the IoT services have been now segregated into 3 ways. My dear faculty members, these are all the IoT services. That's what even we termed it as the application or use cases. Say, for example, home automation or the health services, what we discussed some time ago, or the energy management. It could be possible in case of your electrical technology. It is termed as smart grid. Okay, so all the right electrical gadget can be calculated the data analytics of consuming power on a particular day, and whatever may be the reason, we could be able to minimize the consumption of power, etc., etc., thanks to the smart grid technology. And another one is very interesting. One is your gateway nodes. So the gateway nodes are nothing but some of you, I think, as Professor told, could be cover about your Arduino board and Raspberry board. These are all nothing but physical devices. So like that of our embedded system, these Arduino board and Raspberry Pi could be used to act as a physical devices for computational purposes along with some logical write programming languages like Python, because I offered all those as a case study to my students at this IIoT for your information. And here it deals with various sync nodes where it could be used. And here, the interesting part of the success of your Arduino board as well as Raspberry Pi, especially here, I want to tell one more thing. The success is mainly lying with that of your open source software. So, my dear faculty members, you could understand that the success of our today's mobile phone is mainly, you all aware that, right? We are having Android OS because of its openness. Yes, now it proliferated almost more than 80% throughout the world. Similarly, the success of your physical device, such as your Arduino board as well as a Raspberry Pi, is lying with the top that's your open source. Okay, and in particular, the Raspberry Pi and Arduino board could be used along with the top your Linux, because Linux is also a popular open source. So you could find a lot of projects because it is not my intention. Just I want to give some overview. So please refer if anybody is interested in that. And the success of this IoT is lying with the top. The fourth thing from my perspective, yes, the first one is the use cases or application. We have to have from A to Z application with respect to our today's IoT technology. And second one, definitely we have to thank the big data and the big data analytics, because today's technology is all speaks about your data only. And earlier, KB, MB, GB, but as on date, beta, zeta, and even more than that. So these two technologies, application part as well as the big data part, along with the top your connectivity and communication. Yes, from this point, earlier we have to have a lot of technologies, what we termed as computer network and fast Ethernet and your ATM network, that is asynchronous transfer mode networks, etc., etc. But today the connectivity is very popular, and thanks to your wireless technology also. Even I used to tell that even now it is now crossing almost fifth generation technology. With respect to our cellular mobile technology, we crossed the first generation, your second generation GSM technology, third generation, your WCDMA, fourth generation, LTE, long-term evolution, and fifth generation WCDMA, and the latest on your OFDM concept, orthogonal frequency division multiplexing concept. So that is left to electronics people. And finally, we have to have a lot of devices, powerful devices with consumption of less power with the high processing speed. So definitely these four even I coined. So these are all my own presentation from my perspective only. Okay, so these are all the various ABCDs of your IoT for its success. And this is what we already discussed a lot. I don't want to discuss much about it. Okay, this is what we come across with respect to our IoT. And as already pointed out, the success is lying with of your big data. Even I rated today, it is quintillion. That is, you just assume that, okay, 10^18 bytes of data are available. And I think it is 1 or 2 years back, I had that particular data, right? Even it crosses now almost, okay, some 40 quintillion or even more than 50 quintillion. And with respect to big data, I want to share one more thing. Why the big data play a vital role as of now? I want to see the transition. After 2000, there was a big revolution and evolution in the field of multimedia in particular. Even I purchased, even at 2005, for my personal, I purchased a computer. During those days, I don't know about all those multimedia, etc. But the real heat has been covered, particularly India, only after 2010 10, we have to have the technology called multimedia, and that was realized and introduced in our all the systems, so that only we have to have a graphical card, etc., etc. The main thing of your multimedia, wherein we used in 1970s and 80s only the telecommunication, especially voice communication, where that could occupy some 3 to 30 or 300 or 3 kilohertz only, our voice communication, and whereas your video is in terms of mega. So naturally, in addition to that of your voice, which is very less in bandwidth, we have to accommodate the video, some textual content. The textual content is nothing but our text. Even I used to send 1K only, hello, how are you, etc., etc., using email. But as on date, even a small guy can able to send all those his birthday parties and the multimedia streaming. Everything is possible as of now under the banner of multimedia, wherein you could able to cover, yes, unstructured data, not only the structured data, but unstructured data, as well as your semi-structured data that could incorporate your voice, video, image, picture, multimedia streaming, etc., etc., thanks to our various platforms. Even I used to tell, right, various social media, just like that of your, right, WhatsApp, like that of your Twitter, etc., etc., and thanks to sensor technology, that could be find a place in almost A to Z applications or use cases. And in particular, for your information, today some of my research students are also working on medical sensor IIoT, for your information, because it is so much complicated pertaining to your medical sensor, and also high reliability have been given to your medical data. So naturally, the high precision and high accuracy have been governed under this. We have to deal with algorithms like your deep learning, as well as other learning concepts are very, very important one. So the important thing with respect to our big data or the global data can be governed by this. This is just for your understanding. I am giving this particular slide, wherein the usage of global data increased many-fold time from year to year. And with respect to our next point, what we discussed some time ago, the connectivity, as I already told, the machine-to-machine, WASN, Bluetooth Low Energy, Zigbee networks, in particular your 6LoWPAN, which is used in your IoT, as well as IP version 6. Mostly now we are using it. And with respect to our wireless local area environment, we have to make use of wireless fidelity, Wi-Fi, etc., etc., and the long-term evolution like cellular mobile technology, 4G, 5G, and from the perspective of industry, now they are going for the introduction of your 6G networks. So this is for your information. I'm having this, and the next part is lying with the top SCADA. Okay, because as Professor has requested me to provide a sort of the need of IIoT with that of your conventional SCADA, it is my duty to demarcate what is SCADA and why we go for IIoT, because it is order of the day to introduce about your IIoT. It is my profound duty to give a glimpse of your SCADA technology. So what is SCADA? Okay, so SCADA is nothing but supervisory control and data acquisition. I think here also we come across data, but for your information, the data what we had built under SCADA technology was very limited. So it is even I am rated it as in a local environment only. So definitely in a local environment, we are dealing with various data. Even for example, let us assume a simple lathe shop at Nilambur. So they have to have some data in operating your simple lathe with minimum data only, since it is local. But now assume the scenario wherein if they have to have some sort of MOU with the CIT and they are going for some SaaS, software as a service, they have to download it at periodically, because it is also cost per usage basis like that of our email. So like that of the data here, they have to operate at many fold times. They may go for some modernization, right? So naturally the data have to be very big, and at the same time the supervisory control is lying with them. Okay, but previously it is not so. So only locally they have to operate and merge some sort of manual control, and to certain extent some simple automatic control only. But as on date, the trend has changed a lot, wherein mainly they are using it for process control. Even I viewed, apart from your CSE or IT or your electronics, most of the process control mechanism is lying with the top your chemical industries and other process industries, wherein they have to get all the data on a real-time basis. Okay, so definitely you have to deal with all the real-time data. Even I used to tell your meteorological department forecasting, yes, as on date, what about the cloud movement, the direction of air, the direction of wind, etc., etc. Accordingly, they have to have some sort of simulation part, and based on that simulation output, they are providing some sort of feedback or some sort of forecasting. Within another 2 days, we are expecting heavy rain, to big heavy rain, etc., etc. And at the same time, the connectivity is very, very important. Yes, you have to consider from remote location. So since it is a diversified environment, you can view not in a local fashion, you have to view in a remote fashion with many diversity, and accordingly we have to make some sort of control mechanism. Okay, so these are all the some of the snippets pertaining to your SCADA technology, and the root of your SCADA is nothing but the very important one is here coined by this. Yes, so this is a very simple SCADA system wherein you could be able to manage your simple control mechanism in process industries, in chemical industries, and other industries, even car manufacturing, your production unit, by means of this SCADA system. Yes, we are having all the computer and control mechanisms wherein you could be able to address the land environment, the man environment, and if possible, even used to tell the simple example. Maybe at Nilambur, you may have some unit pertaining to the production unit. And in this case, you may have your main corporate office maybe at Chennai or Bangalore or Delhi. Here, wherein you have to interconnect in a WAN environment. Yes, the production unit data have been governed by means of top level management, those people who are sitting at Bangalore or Chennai. So it is a glimpse of it. So the usage of your land, yes. The usage of your man, yes. The usage of your van, yes. Everything have to be governed under SCADA system. And the very important point which is your SCADA system is lying with that of your security measures. My dear faculty, as of now, it is also play a very vital role, the security mechanism, wherein lot of hashing techniques, lot of your DES, EES, AES encryption algorithms are now come under the picture, and you have to concentrate on that also. So the conventional SCADA system, though works under your basic workstation model, LAN, the firewall mechanism, all those things, something is missing. So here, the something will be realized in the subsequent slide. Okay. Yes. Yes. Now, or IIoT and SCADA are the same? Definitely not, because conventionally we use the technology for various process control mechanisms and various mechanical, production, chemical, etc. But all IIoT and SCADA are same? Not. Yes, the very first one, there could be some demarcation between your IIoT and the SCADA system, and their implementations are very, very important. Okay, the implementation part of your SCADA system is very conventional. Okay, but at the same time, today's your IIoT is entirely different thanks to both your hardware and software and various tools, and in particular various open source software tools which are now available, because I have to cover that particular part in my latter part of PPTs. Okay, yes. So these are some of the salient features of your basic SCADA system, wherein we are much more interested in multi-level networking. That's what I coined the term called LAN, MAN, WAN, etc. But those network entities are at a very low-level concepts. Here we are not speaking about whether it is possible to have IP version 6, or it is possible to have a unique IP address, etc. These are all the main features of our conventional SCADA system, wherein the low-level abstraction, even I use the term called abstraction, the basic networking concepts are used, and mostly which are governed by means of your wired network. But as of now, it is not so. And earlier we have to have some firewall mechanism, some tunneling, etc., wherein you could be able to apply all those technologies not at a cost-effective way only. We have to have a proprietary software. Yes, we have to have proprietary. You all aware that it is not free open source software. There is a lot of limitations in using the proprietary software, because huge investment is needed. So that only I use the term called SaaS. I think for your easy understanding, the softwares are very, very heavy. So in that case, it is better to go for hello. Hello. So hello. Is there any some disturbance? So naturally, the proprietary software, the cost is very heavy. So now we are using open source softwares and the protocols like your ZigBee or 6LoWPAN, etc. It could be possible to overcome the difficulties what we encountered under SCADA system. Okay, and another very interesting phenomena, because last 2 months ago I had a meeting with some of the industrial experts regarding the effective usage of IIoT in their industries. You all aware that Coimbatore is mostly for its foundries and lathe and other small and medium scale industries. I had the opportunity to meet some of the alumni as well as some of my friends at industry. There was some sort of red tapeism in adopting your IIoT because of its the main thing is about the technology. So the technology, yes, they are not even today familiar with the IIoT and other stuff. And the second one is they are very much fear about the cost. For your information, my dear faculty members, the initial investment may be some technical relevant as well as some cost. But once if you make use of all those softwares and the hardwares under virtualization, etc., definitely there will be a big boost towards your ROI. That is what from management point of view, return on investment. So not much in case of your ROI. So even I recommend, because my department is also some sort of industrial flavor, and we have to have some sort of guidelines to them. especially small and medium scale industries. So we are providing some sort of know-how about IoT to the small scale and medium scale industries. The main thing is unwillingness to change, because they are considering the existing or the conventional SCADA is quite okay, but at the same time they are not in a position to hugely invest initial cost, a huge investment pertaining to IIoT. So these are all some of the points why even today we are speaking about IIoT, not give much room for our small scale as well as our medium scale industries. That's what I use the term called this. Yes, cost is the main factor initially. So the people are not very much interested to heavily invest on your IIoT. Even I want to give some case studies, because in this 12 o'clock after that, I want to give some overview. I want to tell about this and how we are connecting the costs. Even you compare this with that of your journey towards a safe journey and enjoyable journey. Yes, each time we have to experience as that of BMW, right? Even a small car like Nano, yes, the answer is nothing but our changing attitude, right? So with respect to our IIoT also, instead of going for SCADA, some sort of change in the mindset of our today's entrepreneur, today's our small scale and medium scale industry owners, with respect to your process industries or with respect to production units or manufacturing industry, definitely they go for it. So from my viewpoint, yes, so we have to upgrade ourselves, right? So we have to provide some sort of point solution to all those things. So we have to govern the mechanism with the top a flexible as well as a layered architecture. That's what we governed under your maybe various entities associated with the top your computer network system as well as your TCP/IP model as the top our internet model, where we have to provide the maximum coverage to the top two things. Yes, the first one is the data. Yes, that is the first and foremost because of our huge data as of now. And second one is, since we are dealing with SCADA system, automatically once we are dealing with the SCADA system, automatically that could be possible and mainly used for our real-time analytics only. So I think you all understood the importance of these two and your IIoT, and some sort of integration could be possible using your some alert emphasize as well as your preventive maintenance and also the integration. So with respect to integration, I want to quote one simple example. That's also I read out from one of the famous article Auto, wherein earlier some 5 years back, using your SCADA system, it is possible to output one car for your information within 13 days, 13 days. Okay, but as on date, it is possible to output one car in 12 hours. Now you assume the voluminous as well as the processing, the production, manufacturing, dyeing, engine manufacturing, etc., thanks to your integration, and that is now realizable in the form of Industry 4.0. Okay, if time permit, I could able to touch upon that also. So the technology as well as your architecture part of both IIoT and your SCADA system are definitely not. As I already pointed out, the technology is entirely different for your IIoT with respect to your SCADA system. So what are all the things we have to implement? Okay, yes, the implementation part mainly contains the important hybrid messaging platform. So that is nothing but how we make use of various devices even your IIoT or IoT devices and dealing with the power, whether you could able to accommodate more power or usage of less power to the devices used in your IIoT, etc., has to be provided, and everything is at a real-time environment with much flexibility. So these sort of technology have to be implemented, and here we have to evolve with the top a timeline, because the timeline pertaining to our IoT is very, very important. So I think all the gadgets, what we could able to, even Professor Senthil Kumar, right, spoken about all those things. I don't want to touch upon that, but I do a macro view how it is possible in IIoT using various Microsoft Azure, Spark, right, Amazon Web Services, etc., Cassandra, right. All those things have been combined together to deal with the various entities of your IoT services to any unit. The unit may be a production or manufacturing or the chemical processing, etc., wherein all those events have to be governed, and we have to have the external data sources. Yes, data as already told, and that could be possible with various storage. So here I want to tell about all those entities. Here, devices. Yes, IoT device are very important. Even I rated this as a physical devices. And the next, the connectivity. That's what we come across the networking. The connectivity of both wired and wireless. Okay. And the third one is very important one is storage. Because as of now, the storage play a very vital role, and wherein we have to make use of NoSQL or SQL database, etc., and the storage have been governed by means of a document database, external data storage, semi-data storage, internal data storage, etc., and everything could be possible thanks to your data analytics. And here I am speaking about analytics, means thanks to your today's machine learning and deep learning. Okay, so lot of algorithms have been governed under analytics. It is also very, very greeny field, and especially faculty, those who are poised for any sort of research or PhD registration and for any sort of advancement could be governed by means of various data analytics tools, Hadoop, etc., for your information. And finally, that could be possible for various actions as well as various applications. We make use of various device connectivity with the top the presentation tools. So it gives a simple glimpse of your how your Microsoft, because it is very famous and mostly used in today's environment, how that could be possible using your Microsoft Azure. Okay, and what are all the various things we have to consider. So it gives a glimpse of IIoT. My dear faculty, please have it in your mind, and how it could be possible. Yes, we have to have an event hub wherein we have to make use of your conventional HTTP or message queuing telemetry services that is very popularly used today's IoT. And naturally, we make use of the cloud-based environment, and at the same time, we are dealing with the data retention capability of storage capacity with a real-time environment with low latency, and your flexibility or scalability with the top all the events like stream analytics, right, cloud via, etc. So many tools are available. Please refer all those things. Okay. And next is very important one is, yes, stream analytics. It is exclusively used for your real-time analytics, exclusively for your IIoT. Here we have to have some sort of events, not few. If I am talking about industry 4.0, parallelly it is possible to output at a car within 12 hours you just imagine the voluminous of data, processing of data. We are in a position to go for real-time environment with millions of events within a second. Okay, now you assume the voluminous of your data, and all the data is also dealing with real time. Even a small flaw in your data handling, the accuracy is a very big question mark. So we have to deal with millions of events per second. At the same time, we have to keep up the criticality as well as the reliability, accuracy, etc., etc. And thanks to your familiar SQL based languages, and at the same time devices like routers, not only static routers but your dynamic routers. And here I want to tell pertaining to routers, even today, now Cisco outputted intelligent routers where that could be embedded into most of the popular industries throughout the world, because Cisco is the pioneer in our router technology. They are having today your various routers for both wired and wireless space. And this is a simple example where the stream analytics enabled by means of your Windows system. This is just for the glimpse of it. Don't worry, I am giving only the overview. Don't mistake me. So I think definitely these sort of mechanism will boost you to more concentrate on your IIoT and the data analytics part. So it has to be provided from various sensor readings, your timestamp, because the validity, okay, and we have to have some sort of throughput analysis, that is real time. And your hopping technology, hopping is nothing but from where to where, how many hop you could be able to reach the data from source end to destination end. So that is a different one. I don't want to much discuss about it. And various service buses what we are dealing with, and the service bus is also another entity or used along with your IoT Power PI, wherein that has to be provide all the reports what we needed. Even I used to tell to that within one guy is at corporate office at Bangalore. He may need some of the inventory mechanism from Neelambur unit. Yes, so within another 1 week, how many cars we are in a position to output it? Is there any stock verification? Is there any inventory mechanism like availability of all the raw materials? Yes, within another 2 minutes, I can able to tabulate it to my boss, maybe located at Bangalore, by means of various reports, make use of millions and millions of data set. And the dashboard is nothing but it is just to provide all the data in a snippet or in a tabular form. Okay, the dashboard. And the Power PI is also another one thing you have to concentrate, wherein we could be able to make it possible in your IIoT. And the next is your BizDoc server, wherein it could be possible using all those server mechanism with the various protocols, whether you are dealing with a conventional SCADA or you are dealing with today's IIoT, the protocol integration from a wired one to wireless one, yes, it is possible. And how the data format supportivity and how it could be possible to output it in a tabular format or pie chart format, etc., etc. Everything has to be taken by your server, and at the same time, routing mechanism is also the part and parcel of your BizDoc server, wherein you have to give due weightage to that. For example, if your corporate office from Bangalore, you want to get the connectivity to your Neelambur unit, unfortunately, on particular day, your VPN, which your private network, you are having the VPN, but it was totally destroyed by some other wind and some other cyclone. But even at this juncture, you could be able to make the data to your boss located at Bangalore. How it could be possible? How the server configuration? Here you have to deal with RAID servers as well as that's what we are now speaking about with respect to IoT big data, we are speaking about virtualization. So to those who are interested, please concentrate on that. And all those stuff have been governed by this. Okay. And here your various apps pertaining to your Azure Logic apps for the notification, your SMS, your email, your WhatsApp, your social networking, everything is possible. And don't forget, yes, as I already told, it is all now cloud-based. So that is the success of our today's IIoT, thanks to your cloud-based environment also. And the SaaS connectivity, software connectivity is also possible using our basic demo model, how it could be possible using telemetry architecture. As already told, the location may be at a different location, but by make use of various tools, it could be possible, right? And your telemetry architecture here, the simulator, what we are going to deal with, how a event hub can be connected, how the various tag values and synchronization and asynchronization of data have been governed under all those things could be possible. So these are some of the stuff pertaining to your understanding for your information. And there is nothing but stream analytics input and how it could be possible, right, for your query based mechanism, as well as the various business talk processing mechanism, everything can be governed. So here I want to tell one thing. As of now, your JSON, right, it is also quite popular along with some other services offered by XML advanced version, etc., which are used for your IIoT environment. So these are all some of the things we have to have it. Okay, how we could be able to possible using real-time visualization architecture using your Azure technology. See here, we make use of all the software tools what we mentioned earlier. Okay, so these are some of the stuff I want to refer. This is pertaining to Power BI, and this is with respect to your query using your real-time visualization to provide all the data in a graphical format, so that it could be offered to some of the members. Maybe your top level management offered everything in terms of visualization effect, maybe your PPT or pie chart or your other mechanisms. Yes, and these are all nothing but how it could be possible. The absence of event have been identified by means of this demo purpose, and this is the absence of event can be everything is on GUI based. You all aware that in our desktop or GUI based, right, it is quite easy, even not much technical knowledge is needed. So naturally we have to have some sort of GUI based connectivity, and this all for the monitoring purpose and other things, monitoring with the BizTalk, and how this particular technology has been used along with this. So from my point of view, I want to curtail within another 5 minutes because the SCADA is quite good and best, even I rated. But at the same time, today's we are having another technology which is fully governed by our latest technology, and two things are very important. The connectivity is no end. Global connectivity is possible, and at the same time, real time is possible. So definitely, as on day, pertaining to your any sort of industry, whether you are dealing with a small scale industries or medium scale industry or large scale industry, everything is possible using your base of your IP address. As already told, it is possible using IP version 4, you have to have a unique IP address for a machine. Even I rated this as a machine as a host or node or a computer. But today, using your IPv6 supportivity, right? It is possible to interconnect various things. That's what I already told, various devices. Even my pen could be IP enabled. It is possible, right? Remotely, if I am sending something through my pen, you can able to download it and even view it, thanks to all the IoT stuff. Okay, so these are all some of the, from my point, don't mistake me, professors. So these are all my presentation, my observation with various industrial persons and myself. Definitely the lessons we have to, right, learned from our previous SCADA and IIoT adaptation. Some driving force is needed so that our industrial experts and industrial entrepreneurs could be able to make their positive decision. Okay, so only by means of testing as well as learning experience they have to learn it, and also they have to provide yes to new technology, and they have to adapt it in a holistic way. And at the same time, some of the pitfalls even today we are going to address under IIoT is lying with that of your security measures. Yes, we have to concentrate. Yes, please. So we have to give assurance to the top security measures to all of the technology of today. I think now, fortunately, that technology is also evolved very advanced version, and we have to decouple the problem with the top your data and analytic nature of all the technology, especially if you are dealing with big data, and also the various topics with respect to your IIoT could be visualized by means of this. Yes, challenges we have to have pertaining to all the industries from small scale to very large scale industry. We go for plant modernization, wherein you could be able to minimize the cost so that it is possible. Tata Group, Ratan Tata could be able to output at a nano car with 1 lakh. You please imagine that. And another one is the flexibility in investment. Yes, that is a economic viewpoint. I don't want to depend on that. And the third is pertaining to ours. Yes, we have to reduce the dependency, and we go for an integrated environmental approach. Especially this is attempted in our today's industry 4.0, the integration. And at the same time, from the perspective of technology, today we are having somewhat expensive software, proprietary software. So slowly we now replace with the top inexpensive open source software. That is also possible. And with respect to hardware also, I am very happy to announce you that as on date, due to the technologies on your virtualization, the cost is also very much reduced. So the amalgamation of both open source hardware and software, it is possible, even that would be made possible to modernize our existing plant. So that will be our next target. Maybe if I am talking about industry 4.0, now only we realize, but my dear faculty members, even now the flavor of industry 5.0 is now realized at Germany, because that is the main focused area throughout the world. Germany is a top player in industry 4.0 and 5.0. So naturally, so we have to have the various technologies to support all those things. So definitely it is possible by replacing the existing technologies with the top, especially IoT, all the units from small scale to large scale. It could be go for modernization with small investment, so that I carefully use that. Instead of expensive proprietary software and hardware, we are making use of inexpensive open source software and hardware. It could be possible so as to make our India from a developing nation to the top developed nation as envisioned by our APJ Abdul Kalam sir. Okay, so I want to conclude with this. thank you for all for joining with me at this, because another event I have to attend by 12:40. I cut short some of the portions, and thank you one and all. So if anything else, please, any queries? Hello.
What's the scope of this IIoT, sir?
The scope of IIoT, very interesting that even I used to tell some of my 3-year back alumni students are now starting their modernization of lathe, because his father is running a lathe section, and very fortunately now he introduced this IIoT for the lathe section at Coimbatore. I think Siniyambalayam, if I remember correctly. So the lot of tools are now make use, so that it is now industry ready. So that is my personal observation from CIT. And the second one, I want to tell about the cloud. Some of my alumni students are now engaged in the business of offering cloud services to some of the small scale and medium scale industries, not a very big company. He just started some 2 years ago only by offering some cloud services to the local small and medium scale industries. So these technologies definitely will play a very big role in future. So as a technical guide, the faculty members and the students should definitely cultivate the habit of reading all those technology. Even I rated this as ABCD, etc. Okay, your AI, big data, your cloud computing, data analytics, IoT, etc. So that only I started with the talk. AICT requirement expected from faculty as well as student as of now. So any other doubt? Please feel free, because I am here for another only 12:40. I am having another session. So within another 5 minutes, you are having the privilege to ask any questions pertaining to IoT and IoT. Right? Please.
Excuse me, sir. Excuse me, sir.
Please.
Sir, will you say any one application, that is any project type applications for the students in industry area?
Yes, madam. Even for your information, I used to tell the term called use cases. Okay. So in particular, even some of my students, I offered some mini project for them in IIoT for home automation, using a very, very simple technology, using your Raspberry Pi hardware and using Python. So I think within another 1 month, they are in a position to offer that home automation. We just mimic a room, especially, right, with the usage of your Arduino as well as the Raspberry Pi. But mostly I recommend the Raspberry Pi, because the cost of your Raspberry Pi have been very much reduced as of now. Almost now it is equivalent to Arduino board. So smart grid, smart city. So for example, how smart city? So if sun is set, automatically the power lights can switch off automatically. If almost by 6+ in the afternoon, the evening, automatically the power is switch on. So some sort of your feedback mechanism, control mechanism, thanks to your smart city. So that is also your IIoT, because if I am telling IIoT means now it occupies all the use cases from A to Z. Okay. Please.
Thank you, sir. Thank you, sir.
Because another thing I want to tell about your Big Hive, Cassandra, because I limit myself due to time, you please refer. Lot of tools are available. Open source tools are available. I offer to my research student as well as some content minimum to my UG students. So lot of software tools are available pertaining to your IoT as well as big data, cloud, etc. Please refer all those tools. Yes, anything else? Hello? Professor?
Yes, thank you, sir.
Very much. Thank you very much, ma. If anything, please send a mail to me. It is
Sure.
my official mail ID. So
Yes.
any research topics as well as any right tools you want to please make a mail to me. Okay?
Sure, sir. Sure. Thank you so much.
Thank you. Thank you. Yes, Professor Sendila, sir. Hello.
Sir, going to classroom, sir.
Oh, okay. Those who are from Sakti Polytechnic.
Yes, sir.
Yes, Neela Hankaran.
Hello.
Hello.
Hi, yes, sir.
Who is from Sakti Polytechnic, ma?
No, sir, I am from Valivalam Desikar Polytechnic.
Okay, okay. So if anybody from Sakti Polytechnic, so I think due to my last minute call, I have to join another webinar from my college by 12:40. So thank you one and all for joining with me in this fine morning come midterm. Okay, so this is my profound duty to extend my sincere thanks to the management of Sakti Polytechnic and principal and Professor Sendil Arasu for giving me an opportunity to share some of the points. I am telling that I am not fully covered, but since it is needed, need of the hour for especially industries to focus on today's IIoT, I just taken up this particular session. And have a good day and take care. Wishing you all the best. Thank you, my dear faculty members and students, if any. Thanks and all the best to you. Okay, I am just leaving and withdraw as well as thank you one and all. Bye.